In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel.
Hello everyone, my name is Nathan, otherwise known as Old Man Builds, and we're here with Joe today. What's up, Joe?
Hey everybody, happy Saturday.
What on? Sorry, I'm having a little trouble with this thing.
There we are. Normal format.
Normal, there we go. Oh man, I'm excited. We're going to revisit a topic today, Joe, that I thought was absolutely interesting and awesome, by the way. We looked at going from energy to matter and the transformation and exactly how each step works.
Absolutely. But first, we have to start off. So, Nathan, when are you going to Mars?
I don't know, man. I'd love to go to Mars, bro. Flat out, I'd love to. Don't ever get me wrong, man. You give me a spaceship, I'm going to Mars. I would love to see the pyramid, if they're real or not. The face, love to see it. So
yeah, no, I don't think anybody's trying to be friggin' Elon Musk over here. You know, just playing with some electricity.
Yeah. Just trying to, put things out there, get people's mind thinking, and, show experiments to prove out things. It's kind of fun.
That's it, man. All right. Yeah, no, this is a great topic for this week. And, it's really good that we decided to revisit this one because, we talk about it all the time without really specifying it. But when the last time you and I crossed this bridge and had this discussion, really there's sort of still some stuff that had to be ironed out. I think that the viewership also at that point was a little bit lower. So that this might be really new to a lot of people also that have sort of joined and followed. And I think it's awesome that we're taking another stab at it. And I think that it's something that we should continue to build upon as we get a better understanding of exactly how all of it applies to the physics that we generally look at day to day.
Yeah, absolutely. 100% agree with that.
Yeah.
So, Joe, you're going to be doing most of the checklist here and kind of going through exactly how it works, and I'm going to push in with some comments. So, by all means, start us off.
All right. So, because of the subject matter, I'm going to give a classic straight dope disclaimer that I don't claim that I know anything. These are ideas and theories that I've come up with, and I'm not saying that I believe them to be entirely or inherently true, and I think that things should always be open for debate. But given some of the knowledge and experience that I've had on the subject matter, and then having hundreds and hundreds of hours at this point of these podcasts and everybody experimenting and stuff, I think that this particular theory really kind of got more solidified over time as opposed to debunked. So I think that that's cool, but just know that take everything with a grain of salt, and always question, criticize, experiment, and stuff like that with what we're kind of bringing to light here, not presenting it as some sort of absolute fact. But I think that everybody should find it interesting.
Absolutely.
Yeah. So the theory is kind of this, and it's a multi-dimensional type theory where everything is layered and built upon itself. And the first layer of it is an absolute still and serenity. And before anybody says, well, that doesn't exist, we know that doesn't exist. Well, you have to think outside the box here and just understand that in order for there to be some kind of motion, movement, or potential value, there has to be something at a 0 point, at an absolute plane somewhere. It's just not something that we can necessarily experience, right? So that's the first sort of layer, is this absolute still serenity. And that's before any ether, fabric, anything like that at all. Now, once you introduce a sort of any sort of pressure on that system, a differential onto that perfect zero, because there's now a differential, it can no longer be at a valueless figure. It can no longer be perfectly still. Okay. And that kind of collapses into a potential and ends up being more or less what we would think of as like a longitudinal wave. Okay. A wave that is dimensionally more simplistic than a regular waveform. All right. Through the interaction of those potentials, then you add another differential in to the equation that would introduce frequency into the equation. Now, once you introduce frequency into the equation, you've now crossed over into Planck's, like scale of existence. Before that, they're like time and space are really condensed and more less dimensional. Okay. Whereas once you cross over, now you're subject to time and space the way that we would experience it, and the frequency is ultimately introduced. From there, those sea of frequencies then interact with each other and result in all sorts of different constructive and deconstructive interferences. And it's through these constructive and deconstructive interferences that occur, and partial wavelength cancellations, like figure midsection cancellations, that actually is the manifest of the like fundamental particles that you would otherwise observe. So, you could end up with electrons, you could, anything off of that. And then once those fields are created through different levels of attraction and repulsion, there would then create another set of differentials, okay, that would ultimately lead to density levels and that would be the differential at that point, is attraction, repulsion, and then density levels on either side of what's being created. And really, it's at that point of that you start experiencing fields and field interactions. Magnetism, plasmatic interactions, and all of it works off of a gradient of energy manifestation. So depending on what these density levels look like and what they're comprised of and so on, it will be deterministic as to what the manifest of the energy ultimately is, whether it's electrical, magnetic, or plasmatic, or and the like. Okay, so that's sort of that realm of it. Now, once you start reaching higher and higher density levels of this energy, okay, and it's put under so much pressure, there's ultimately a point of a tipping scale where you end up coming up with atoms. And, it's these atoms that then condense and interact with one another to form more and more complex elemental structures that then do the same exact process. It's just a repeating fractal process. Okay, so
let me ask you this before you go any further. Is there an initial boundary zone in this equation? So we know that you have no frequency, and then all of a sudden you have any kind of semblance of a frequency or waveform, something like that, right? Wouldn't you require a boundary zone of some type to bounce it back or to kill it? You know what I mean? Would there be anything like that?
Well, I mean, you could always think of these differentials as one of either two things. You're either going to end up with this boundary zone, like you're saying, which is two differentials that exist that are in relation to one another, but not mixing or interacting directly in any way, meaning that it's non-diffuse. Okay, so rather than have diffusion zones of different energy potentials, instead you have like more or less a membrane, and of it, where this field ends and this field ends, and now they're up against each other, and at that level, there could be both attractive and repulsive forces happening simultaneously that keep them in some sort of lock but there is absolutely in that case a boundary when there's no diffuse gradient differentials.
Okay.
Yeah.
So that's what I was curious about. You define a boundary, and then I don't think the frequency just runs linear. I think that it's going to go out in every dimension when it hits, or initially maybe on a plane, but in every way. And when it hits the side, that's what I wonder, if the boundary itself is in rotation or still, because you would think it'd be in rotation just a little. It didn't have to be much yet, but just a little bit in order to get that frequency to spin slightly so that it goes in a different direction when it comes off of it, right? And then you start getting your counter waves, and throughout your counter waves, you start to build something off of it, right?
Yeah. So what's interesting about this and how it plays into what you're saying is that this is the reason it's dimensional, okay, is because it goes from levels of simplicity and builds upon itself into more complex, organized forms, right? As you descend down from this absolute still to a potential to to a scalar waveform, to a frequency waveform, to interactive frequency, leftover differentials and charges and stuff like that, and then the consolidation of the charges. It's all dimensional. But when you're in higher realm, like higher degrees of our reality, like our dimension, fourth dimensional space, whatever, right? All of these actually exist simultaneously. Right. So that's important to kind of, realize here. So what does that mean? Well, that means that, if you have these complex fields in differential and they have their own flows, like we know that these things have flows, right?
Mm-hmm.
So these fields have flows. So each flow could be working against, with or against each other, at their points of interaction, which then could affect both lower dimensional processes and higher dimensional processes as well.
Yeah, how do I want to say this? Because you're going to frequency, now you have to make that frequency flow in a direction that it somehow starts making magnetics. It makes the dielectric, you know what I mean? It's got to coalesce into a thing that will eventually make matter out of it, right?
Mm-hmm.
So at some point, the outside of whatever you're building has to move, or the frequency has to be moving when it hits it. It's almost like the frequency hits it, creates an energy source on the outside, then shoots back. But the energy source is continuous on every level now that when it gets around all the way, that you get that energy in rotation. That rotation goes into, any part wherever it decides where those frequencies are crossing, then it has to coalesce together in order to pull stuff in, right?
Right.
So it's kind of, I'm trying to get to the point where we have energy, and then out of energy we can get matter. So it has to be some form of,
Right.
structure.
So once you start getting higher energy density levels, okay, assume for a moment, because I think that delving into the cause of what would the cause of all this be in the first place, right? Like if we skip past that part, because that's like, more occult esoteric than anything, like we don't have to worry about that. If we just focus on the idea that matter already exists in some way, shape, form within this, right? And energy exists some way, shape, form, you have to understand a couple of critical factors to bridge the gap between energy and matter. Okay. The first thing to know is that there is a gradient. Okay. And the gradient really lies within two very principal things. plasma, just generally plasma, okay, and hydrogen. All right. The reason I say this is because plasma is matter like energy, okay, and hydrogen is energy like matter, okay. So they're and they are but very interchangeable, you know, very interchangeable. So hydrogen actually wants to go back to a plasmatic state, be released as release its energy, okay, and be matter no more. Like that's kind of hydrogen's deal, you know. But hydrogen could also be the root of all other elemental matter that exists when it's compressed enough. So once you bridge this gap between plasma and hydrogen, and you realize that the compression of energy on a higher density level of hydrogen type matter could ultimately transmute hydrogen into heavier materials, and we know this through fusion. This is why the sun ultimately, you know, works off of hydrogen turns to helium, right? That's how that goes. It turns into a more complex and heavier, you know, material than it originated.
Okay. So just real quick, a question. High frequency light equals hydrogen. So do you agree with that or disagree?
I mean, it's really hard to say because when you look at, okay, so photons can be turned into matter. And generally the way that would be kind of scientifically currently acceptable that would be the case is if you have high frequency light that's collided with gamma radiation, because those are the two highest densities that exist. Okay. So when you smash one with the next, then there could be you know, element. You could basically collapse the light into matter at that point, and that matter would be hydrogen just by nature of its simplicity. If you do that enough times and you have a high enough accumulation of hydrogen, you know, and then the densities are still there where the pressure on the condensed hydrogen then starts reacting, then you can start making heavier heavier elements out of that. You know, and aside from the elemental aspect of it, you know, then you have certain elements, and when they start combining, if the energy is at certain frequencies, that could influence the arrangement of the atomic structure, which then in turn could lead to new elemental formations.
So here's my only thing to light. In a lab setting, when I go to work on, say, high voltage or anything, right, you can pull the anode and cathode apart and you get nothing, right? There's no visible light. You turn off the lights, you can put, you know, anything, there's just nothing. Now you bring them together, you have light. Now, in some form, you're either getting a static electricity or a magnetic aspect to it in order to pull from the anode to the cathode where you're going to get visible light. Now, it'll start out real faint, real light purple, you know what I mean? And then it'll go into every different color spectrum based on the distance and the amount of rotation. If you put it in there for each one, it'll start changing. I go through every single color of the rainbow in my lab, just simply building them out. You know what I mean? And changing distance. So I have a little trouble with the, you know what I mean, the frequency to light, unless, see, and this is what gets me, when I ran my Tesla coil experiment, it went from pure frequency in that Tesla coil to light in order to create the plasma, right? So I saw visible plasma light coming out of it with no, you know, cathode to it. It was just, you know, basically a wire coming out as an anode. Again, no primary to it. So it's kind of confusing a little bit.
Okay. Well, I mean, I have a response to that. I mean, again, and whether or not this is correct, again, full disclaimer, I don't know that I'm correct about this, but this is what I would figure in that case. You know, when you run certain frequencies. Okay. You would need a certain amount of frequency interaction to occur in order for it to start discharging photons. Okay. What we know about photons, generally speaking, is that they're emitted in photonic packages. And the reason that it's photonic packages is because now, again, we're going back to, frequency wave interference. Okay. And density of that remainder of the wavelength. Okay. So whatever remains, you need a high enough density of that in order for it to be a photonic package. If it's just occurring and then flowing and it's in a form of, near pure resonance and it's flowing, it doesn't actually get to the density levels in that circumstance because it's always cycling. Right. So you need a certain amount of accumulation of that positive offset frequency interference to occur in order for there to be a photonic light emission. That's what I think.
Okay. I think I got that. So he mentioned here, look at white holes. They explain hydrogen. I don't know a lot about white holes.
Yeah, I mean, me either, really.
So I just know what I see when I build things. So I have to take into account that I used a wire to build that. And then at some point I had to hit oscillating frequencies in order to get that. So, at some point we're going to have matter. So the question is the matter always been there in some small part, or has it not? So that's kind of my questions. We don't start out with much in the universe, I guess, when you first start, but there has to be some form of matter somewhere, right? Whether it be in the walls and you're knocking it off the walls or whatever, in whatever structure you got to have something, right?
Yeah, I mean, I think this is sort of where it goes back to, they say Big Bang. We'll refer to it as that for the sake of this conversation, just because it's easy to. I have my own sort of theories on what that really looks like, but that's for a subject another day, right? But
Mm-hmm.
it would actually make sense that if you want to consider the Big Bang as the recycling of energy through a toroidal flow as it enters into the more or less event horizon of compression, right? So you have all this junk outside spinning, twirling, and coming toward a point. And when it reaches that point and it gets compressed and it's about to enter into your center flow of a torus, as far as our perspective of it is concerned, because it's both inside and out reality, right? But when it's entering into that center flow of compression, it's actually going to be like compressed and shot out and continue to be compressed as it reaches the center point, greater and greater and greater. That's the ultimate recycling machine, is what that really is. So in that process of when it's expelled through the center of compression and then put out the other side to an ever expanding back toward the bottom pole of your torus, more or less, right? That could be the manifest of an origin of matter in its original state. What do we know about matter generally? Well, once matter exists in relation to energy, not only do you have the manifest of electromagnetic properties that occur, right? Mm-hmm. But you also have now the seed for differentials that exist between the newly created matter and the energy, which ultimately that seed could build and grow. So you have matter that attracts to other matter, creating differentiations and densities that exist with the energy that's actually in a diffuse state. It's actually getting the energy is getting sort of weaker as it travels out. So the matter actually overcomes the densities of the energy, and it can actually build in resonance through its greater pressure differential, if you want to call it that.
Hmm.
Yeah. But like
Interesting.
white holes, black holes, I don't know who said that a minute ago. Like, I mean, I don't know a ton about that, but like, I mean, if a black hole's a mouth and white hole's an ass, I mean, it makes total sense why it would suck in whole matter at one end and blow out pure potential hydrogen out the other, because of that exact same mechanism. It's making it into the most simple form. It's like a form of digestion. You know, that's sort of what it is. It's like cosmic digestion.
An interesting way to look at it, I guess. Yeah.
Yeah.
So yeah, see, I always wondered, like, if you get to the like the asteroid belt, right? And it's kind of like a null zone where, you know what I mean, you don't have anything in, there's no planet, there should be relatively no gravity. I'm sure there still is, though. But right there, if you start setting off frequencies and stuff, I always wondered, would some of that stuff, obviously if it was small, would it start to coalesce? You know what I mean? Would it start to form around it? If it had the right properties, and would it start to form something more? You know what I mean? Just by that one thing.
Yeah, that's sort of where I'm going with what I was saying. You know, once you have that seed of matter in a sea of energy and potential, that matter is going to want to actually attract to it all the and that is the gravitic force, by the way. But it's just at such a different scale and level. If you're talking about a speck of dust that's accumulating other specks of dust, it doesn't seem like the same thing.
Well, it doesn't have to start large.
The same thing. It is the same thing. Yeah.
Yeah, you just need something to start moving. That's really what it is, right? So if you had like a point where the frequency is, and if something starts moving around it, it starts to make the fields that you want, right? That's pretty much what we're looking at. If I started with the frequency and the frequency itself started some kind of movement in it, or created an energy value in it, and that thing started to move in any way in that toroidal shape, then it starts the process of what we need to go.
Yeah. I mean, I think that one thing I just in a train of thought, I just like reverse thought of an idea that we've already kind of touched on, right? Mm-hmm. But the inverse must be true too, right? So if you have electromagnetic properties that are manifest in the presence of matter, right? We know this to be true, right? Then what does it mean if you have matter that exists in a void of little energy? Then at that point, like, what, you know, does the manifestation of matter start accumulating greater and greater and greater and greater? And I think the answer to that is, well, yeah. And that's why one of the most observable things is that this closer to the sun you have smaller planets made of denser sort of materials, right? And then that goes into another episode that we touched on a long time ago, which was, you know, energy matter depletion and plasmatic depletion of hydrogen and all that sort of stuff. But so we don't need to touch back on that. But, you know, it's like, just think of it about the size of the planets as you move further and further away, and it works on a gradient, right? It starts like small and kind of gets bigger and more complex, and then starts being more desolate, but then also then becomes larger. But the larger is unusual because those are simpler types of matter, generally speaking, in their composition, and larger in size. And that's all because of the matter to energy gradients that exist in our solar system. You know, and if those same gradients exist beyond the solar system, and they exist in the galaxy and the universe, then things start to take on like a much more logical train of thought as far as, you know, how this all came to be, like how it is.
So, interesting thing, I was just thinking about this in my head. If you say there's hydrogen, right, and that's the primary, first thing you build. The next thing, if you're building electric fields, that you notice comes out of things is O3. You know what I mean? You're getting that right away. As soon as you can create any type of plasma, you have it. So the question is, we always say that there's no water in space, which is untrue. There's water in space. But is it that connection right there to the H2O, you know what I mean, breaking and forming it inside of an electric field that allows it to grow something more? So if I had water and I put frequency to water, it starts to create things. If I do that and then I'm breaking and pulling things apart, I can make crystal very easily in that by just forming it in certain frequency patterns. You know what I mean? Just for get the oxygen. So it's kind of interesting, the building blocks of everything. I would think that the first matter wouldn't be like a stone or a rock or anything like that. It would be some form of crystal structure, wouldn't it?
I mean,
forming the
I would have to
primary
say
thing?
that I mean, I would have to say that that's absolutely correct. You know, just based on what the root cause of it all that we talked about earlier in the show was. You know, when you're talking about you know, different energy condensations of a specific root frequency, and in an environment saturated with certain resonant values, I would say that would be deterministic of the initial matter structures, and they would probably be crystalline in form.
So if we know that and we're building out these things, this is what's so interesting, because you get into microwaves and then they can grow crystals faster, right? Or you get into certain frequencies that they have to deal with. And then we know crystals themselves have frequency. They also have magnetism that goes along to them. We know that they get electrically excited when they're in water. So it kind of makes sense that those would be the elements that are created first. Now, when we go to the next structure to get more complex, is it simply have to do with the frequency putting into those items, like into the water, that creates the matter?
Yeah, I mean, well, that makes total sense, considering that, you know, science for a long time has always looked for water as a sign of life, right? And they always kind of presented it at the basic level, okay, as well. You know, we look for it because everything that exists in, you know, on our planet, as far as we're aware, that shows signs of life, is dependent on water, right? And that's kind of the gloss over explanation of that, is what that is. You know, the reason that water is the critical thing, yes, everything more or less to a certain degree depends on it, but it's really just as a matter of what it is, and it's everything that you're saying. It's a medium. It's a, you know, water is the matter equivalent of ether, is what it boils down to. You know, you could create voids in it. You know, you could break it apart and, you know, use it for other functions. It's a source of both it's a source of both energy and destructive matter, because remember something, oxygen is also the destruction of matter too, through oxidation. So once you break water apart into its, you know, fundamentals, you're left with something highly volatile that'll easily return back to a pure energy state, you know, and then you're left with something that's willing to also be able to break down most other forms of matter, and ironically into, you know, oxides. And these oxides are more permanent matter than anything else. You know, oxides are almost permanent matter. Like, there's only so much you can break them down.
Yeah, I find it very interesting that in order for complex elements to form, sometimes they have to have water. You know what I mean? Like, it's strange, because let me say it this way: if we've already coalesced the energy and we are now transforming hydrogen into more complex things like water, okay, we already have that set up. Now we go in there, and now I want to break everything down again, that means that I have to have structure, number one, to build it. And then I have to have a negative which releases structure, right? So we see with the energies that we build, if we took a 9-volt battery and put it in water, we can create structure. If we took the negative energy that I built out of the center of my Tesla coil and put it in there, it relaxes the water. So it's interesting to just think about it that way. If you say one side of it's positive, one side of it's negative, that means that in one side of it, you're absolutely constructing something. And at one side of it, you're absolutely tearing apart.
Well, water is a liquid crystal, no doubt. That's what it boils down to. It's a liquid crystal.
Yeah, it really is. The cool thing is when you get something that interacts with the crystal, right? And it has to be through a medium of water. That's the most insane part about this when you start to break it down the way we did, is that now that you can communicate with it, you know you found the other side you were always looking for. See, we live in a hot energy field. We go outside, the sun, hits the top right there in our ozone layer, and then it makes energy that presses upon us from there. So we're in a hot energy field. We don't know what it's like to be in a cold energy field. It's completely different.
Yeah, no, that's true. Limited State said that all elements can theoretically be made of by just compounding hydrogen. I mean that's the exact point that we're bringing up here, is the relationship between plasma and hydrogen, and how plasma, the same as hydrogen, could be theoretically the root of all other elemental matter. Plasma is also the root, or the most complex form, okay, of all the electromagnetic and energetic manifestations as well. So, you're on one side, you're dealing with bridging the gap between the most dense energy versus the least complicated matter. And that is the gap that we're bridging here. And that's why this episode is the descent of energy to matter.
So here we go. This is the Russell scale. Toymaker asked me to put it up because I think it would be actually one of the most important things to look at, isn't it?
Yeah, I've seen that before once or twice.
So what I love about the scale is it has to do with frequency octaves. Mm-hmm. And it takes a gaseous form and puts it into matter. That would probably make more sense, wouldn't it? So you'd have some form, and it always says hydrogen's here at the very top. And then it breaks it down to every single element thereafter, right?
Yeah. Well, with any kind of this science, no matter what subject matter, you're really looking at, it all comes down to two things. It's diffuse gradient, and when you look at this and how it's broken down into octaves, you could actually see which elements are related, even though they are seemingly unrelated. Mm-hmm. And how certain elements are just more complicated forms of a more root cause. And right at the top of that is hydrogen. So hydrogen is the mother of all, as far as that's concerned. Actually, yeah, literally the mother of all, because that's the matter form of it. Once you bring that into, we said before too, and I'll kind of tie a nice bow around it for you. The animating force, okay, is plasma. All right. So when you take matter and plasma and you have them in the same area, that is your animating force. Now, that animation could be as simple as elemental construction, or as complex as taking something that has a single cell and a bunch of code and turning it into life as an animating force of that life. So it's just important to bridge the gap and understand how significant hydrogen, plasma, and then these relationships between the elements are as you descend down this, because there are certain elements that you could potentially transmute into other similar and related elements, or potentially one of the same, resonant frequency of another octave. Okay. But not necessarily jump from one to another, like seamlessly.
So let's just go back a little bit. We did the thunderstorm generator, right? And that works on frequency and octaves, right? And it's taking matter, breaking it apart, and then reforming it, coming out the other end. Or it just reforms it back to what it was, right? Depending on how or what's close to it and how it coalesces at the end. I find it very, very fascinating that process, that machine. So let me take this down for a second so we get this clear. The machine has no electrical connection. It's heat, it's cold, and it depends on the vibrations of the chambers, right? That's it. That's where your energy, your frequency, all of that comes from. None of it's electrically done. I think people look over that and gloss over that, and they don't understand. They keep thinking, you plugged in some power source somewhere, turned it on and the frequencies hit, and then none of that's there. If frequency itself is creating the energy. So if you got a plasmoid in there and you have that frequency that's constantly repeating over and over and over again, you're going to get energy. That's what I find so fascinating. You see, in a microwave oven, you get energy put in, it creates the frequency, right? But then that frequency is amplified, like the energy amount, is amplified through that frequency continuously going on by a bunch, right?
Oh, yeah.
So we look at the two and we can say right away, if we understand the frequency and octave of something, we have more energy than we think we ever did. It literally is the source of it.
Well, remember what the oil, what am I saying? That was a Freudian slip. Remember what the frequency of the microwave in your microwave oven is interacting with is water, right? Why? Why? Well, because that's actually amplifying the energy that's in there through its crystal structure form, and the disbursement of this energy that is amplified in its interaction is heat.
Yeah.
Now, what's interesting about that is that when that microwave interacts at that quick moment of interaction, it's a cold energy process. Okay. It's only the manifest of the opposite side of that cold energy process that is the heat that then diffuses through the piece of food and warms the entire piece of food. And that's how that works. Like, it's never explained this way, and it's never explained in these contexts. And, I think that it's super interesting to actually take a different approach at looking at these things, because it's all known information. It's just how you apply it. That's all. It's just how you think about it, how you apply it, and how you apply it to other things outside of putting a chicken nugget in a microwave oven. Sort of it.
Yeah. So interesting, when I did an experiment, I heated up the water, right? Before putting the cold energy into it, the field itself grew by a foot. So I already get a 3 foot field out of this. Okay. If I put it in a jar, put it with water, I can put it in there, get 3 feet of energy from it that I can pick up with a fluorescent, right? Now I gained an extra foot just by making the water hot.
Hot, yeah. Well, right, you've loosened up the structure of what's that usually exists, more or less. What's up, Ben? By the way, hey man.
Hey Ben.
Yeah, man, it's really interesting stuff. It really is when you think about it. And there's so many different angles to really take on it if you think about it. I know somebody said in the chat earlier that what interests them was evaporation. And I tend to agree. Evaporation's cool. But I'll take it one step next. Is you think evaporation is cool? Oh, sublimation is way cooler. Skipping phases and going straight from from solid to a gaseous state is, to me, like, I mean, esoterically, it's something that you want to do with your own life. Okay, but aside from that end of it, the idea of going straight from a solid to a gas state with totally skipping the medium just goes to show how important liquids are in the grand scheme of things.
So
at any temperature.
let's talk about vibration in there. Once you create the heat, it's vibrating the oxygen in the water, right? That constantly moving it so it has more energetic qualities to it, so it pushes the field out further. That makes perfect sense.
Yeah.
I mean, I'm good with that.
Well, that and the densities also change. Again, it just all goes back to densities. Whenever you heat something up and it's preparing a phase transition, the whole nature of the phase transition is the density of what's occurring. It's the same reason as when you take propane and you put it under pressure, it turns to liquid, right? And if you were to pressurize it further, it'll turn to solid. It's the same idea. It's expansion and contraction, and the temperature differentials that exist, the density differentials that exist, and that directly impacts the phase change of the element or compound that you're talking about.
So I got a question for you. Now that we know this stuff, when we deal with the crystals, to build them, you have to put it in warm water in order to activate the crystal to grow bigger, right? So you put the little crystal on the string, you put it in warm water. The warm water itself allows that crystal to grow. So it's creating more, it has to be creating more energy inside of that little cup or whatever it's in, right? In order to do that. That's interesting. So
It is.
if we took hot water to a crystal, normally we put it in cold water, right? You see people setting these things up, they put it in cold water, or room temperature water. They don't really think about it, but if we were testing the amount of energy in the crystal, would we then want to put warm water in it to see if we couldn't get more energy? Do a cold and then a warm.
I mean, it could be, but crystalline structures, once they're set and they're and that's what they are, they probably have, as far as the crystal themselves are concerned, right? Now, are probably set in what their potential is to a certain degree. It probably could be influenced one way or the other, depending on temperature and different environmental circumstances. I think in that context, it becomes more relevant to think about what happens once the energy leaves that crystal in that warm water environment and what that transmission stands to gain, because that could potentially be a cleaner, more pure and higher level transmission from that crystal in that environment. But how that actually impacts the crystal itself once that crystal structure is set, that I'm not 100% certain of. Yeah, I mean, it's the crystal formation in itself works off of those same principles, like you said. And a lot of times when you're talking about different crystalline structures, and geology just generally, one thing that always comes up tends to be, high pressure, high temperature. High pressure, high temperature is how you're going to be able to get super solutions in water to create high density brines that couldn't exist at sea level atmospheric pressures. It just can't, or temperatures. Like, you need that high temperature, high pressure in order to get something to be, I'm making this up, but 65 or 70% elemental ionization in solution or whatever, you can't get that at sea level. You can't get that at ambient temperature. So that stuff is critical to the formation, because realistically, without these super solute brines, none of the crystal formations on Earth would occur like that.
Okay. So, interesting fact that maybe people don't know: if you put pure oxygen to crystalline form, it dissolves it.
Pure oxygen in crystalline form, it dissolves what?
It dissolves the crystal.
Pure oxygen.
You could put it in with diamonds and put pure oxygen in there, and the diamonds will just completely break apart. It's one of the rare things that destroys them.
Oxidation.
Yeah, well, it's pure oxygen in an enclosed environment, pressurized, obviously.
I mean, if you have a diamond and it's pure carbon, and then you put it in a pure oxygen environment, right, there would probably be a CO2 emission. Why wouldn't there be?
It'd be an exchange.
The density is where the issue is. And again, this is the first time I'm hearing this, so I'm postulating on the fly as per usual, I suppose. But just based on my own chart itself that we're talking about today, sure, except because of the density of the diamond in context, right? You would have to have a very high pressure of pure oxygen as well in order for it to. It couldn't just be like, suck a vacuum, pump oxygen into atmospheric pressure, put a diamond in, and watch it fall into dust or something like that, or turn into CO2 or whatever.
Well, oxygen from an oxygen tank, so pressurized, yes.
Yeah, so if it was pressurized, yeah. Liquid oxygen would probably, how far into the stream are we? 50 minutes? Probably fuck it up 2 ways to Tuesday. I got my F-bomb in for the day.
No, one of your favorite channels that you watch, Joe, for that chemical guy, that young-looking guy, super.
Oh yeah, Nile Red, yeah,
he did it. He put the oxygen in there, man, and just completely.
Oh, I remember that. You know what? I have seen it before because Nile Red did it. You're right. Yeah, he got what do you call it? Industrial diamonds.
Mm-hmm.
Yeah, that's right. And they just, I saw this, right? Yeah, thank you for refreshing my memory.
I would love to show it, but he copyrights everything, so I can't show it. But yeah, I just thought it was so awesome, man. It just not many people know that about crystal. It's just the oxygen itself would tear it apart. So the interesting part, and the reason I bring some of this stuff up, is when we get to our crystals that we want to build, and they build on frequency, right? So think about it this way. If you have water that activates it, and then the activation of it and puts energy into it, if there's energy in there, there must be frequency in there. If there's frequency in there in a confined environment, you must have magnetization in there, which crystals do, right? Mm-hmm. So that it starts to explain why we're getting energy out of them when they click together, right? Because those things can form and they hit, right? But now, can we make that crystal more energy by using those things to convert it? So if we knew the frequency itself, if we knew, you know what I mean? If we can amplify the magnetism to that once we have the correct frequency. So my thought is if we put it in the water, it's got to be giving off a frequency. So if we put our oscilloscope into the water, right? And then we try to detect the frequency itself. Now that we have the formula for that crystal and that frequency for that crystal, can we now make some kind of magnetic field around it at that frequency and get this thing to light up?
I mean, wow, yeah, that's a long thought. Okay, that's a tough one. I think that in like context of environmental symbiosis, as far as like if you were to put it in context of like running water over a quartz bottomed river, for instance, right? Mm-hmm. I think Brandon had brought this up of like, hey, I mean, I could feel the energy off of this. I mean, I think that when you're talking about like larger scales, flowing water, pressure on a piezoelectric, the crystal structure, I think that water itself would be a different frequency than the root water in which percolated from the ground or melted from the mountains to feed the river. In that context, if you're talking about taking a single large crystal and putting it in still standing water, I don't know that the effect would be significant enough to be detectable. But that's not to say that because it's not detectable that it doesn't have an effect ultimately on the water crystal structure itself and the resonance of the water itself.
So take the waterfall and just look at it as a pulse wave. So it hits it continuously, right? New forms of water hits it continuously. So we're not just creating a magnetic field just to turn it on, right? So we would want to turn it on like you do a Tesla coil. You want to pulse it at the frequency, right? You want to continuously put a pulse into it. So you're looking for it to tap it and get it to tap back. Now, we know it works on a watch just like that. We tap it, taps back, absolute time, not a big deal, right? So now if we pulse that magnetic field at the right frequency, can we tap the field that's going on inside it once it's activated with the water? And then will it tap back? That's the curiosity there. That's why I ask about the light, because if it taps back, it's not just tapping back once, it's tapping back through all the structures that are exactly the same, because they're all built 100% the same in frequency. So that's why I'm wondering if the whole thing lights up, because then we're tapping it right. And it's going to be continuous. It's like it may start with a little bit, and then grow to the whole crystal over time.
Right. So you're talking about the same thing, like a locality saturation at that point.
Yes.
Yeah. I mean, that makes sense too. It does, and the way that you're now explaining it actually makes a lot more sense to me. And I could kind of get on board with that. Yeah, it's possible. I would say. I also will say that the same exact theory that you're saying, though, I feel like is true whether it's a crystal in water or anything. So anytime you have anything in pure resonance, if you're also tapping into that pure resonance of any two objects in relation to one another, that same type of building and extraction could take place. Now, in nature, it tends to be a pretty rare thing. But when you're talking about consistency and coherence, you're dealing with, crystal structures being a great example of that. It becomes inherently easier, right? Because when you're talking about a piece of wood and a piece of wood, they're both pieces of wood, but that doesn't mean that their resonance is exactly the same. We know this from building musical instruments, right? They have different properties, and even one piece of wood to the next is never exactly the same. Mm-hmm. They have different densities, they have different cell structures, they have different anomalies. When you're dealing with something that's actually built at the molecular level as a crystal structure, repeating over and over and over and over again non-organically, you really reduce the variables at that point, being able, and this is why quartz is used in the context that you're saying and not a piece of wood. That's why that when you're looking at nature around you, generally speaking, these types of interactions don't occur, because everything's resonating at a different frequency, even albeit if it's slightly off. But what you're saying plays a huge role, and it occurs naturally because of the same example that you gave and I gave before. Quartz in a river. You could smell that river from a quarter mile away.
Oh yeah.
That's it. You could smell the freshness, what we consider freshness, right, from a quarter mile away. And why is that? Well, it's because there's all sorts of, first of all, ozone is actually off of that. That's a thing. It's no different than that fresh rain smell, right? So you're having these electromagnetic interactions occurring at a pretty large scale that are detectable by something as simple as your senses, right then and there. So it is occurring. but how to harness that, that's something that I don't think a lot of people had like really delved into or anything.
Well, that's what we're going to get into soon enough, Joe. You know what I mean? With all the crystal stuff that we're talking about and looking at, I mean, this stuff is very, very interesting. And here's what I'm going to say: the bigger the crystal, the more the effect. And I'll say it: when we build something simple, just the shape of it, right, in a wire structure, we get one level of it. But then as we build a second level to that, we get two. And if you keep building them up, you multiply them. Well, a crystal naturally has that structure. So the bigger it is, it means that more structures are built. Therefore, you can resonate more things in there. All it takes is the actual structure itself. I wouldn't be shocked in any way to find out that we're building a hexagon in a piece of quartz, right? And then if we simply resonated to a hexagon shape, right, we'd get everything that does it. Now, does that also mean that each oxygen molecule would have its own frequency? Do you have to get all of them? You know what I mean? Or is it one frequency that is every one of them? It's just an interesting concept, because when you build it into a wire coil based on the distance of the actual, one piece of the wire to the next, when you go that distance, you get one frequency. Then it goes off to another, because now it's like you get a quarter, or a half wave, right? Then you go to the next one and you get another half wave. You get what I'm saying? As you pull around this wire, you're getting different waveforms. So is it the same way when they build the structure, or is it just one frequency?
Listen, I want to tap into that with you, but before we do, can you send Brandon a link, please? I sent them one earlier, but I don't think he realizes.
I know we want music to play, but
so I
send it to him.
I'm sorry. I was kind of like absorbing a little bit of what you said, but I think I might have missed some of it too. So if I'm off base, just stop me before I get ahead of myself. All right, but when you're talking about the manifest of different electromagnetic properties that exist based on spacing, that goes actually directly into the whole idea of this concept of descent to energy to matter that we're discussing. Okay, so whenever you're running a waveform through a piece of matter, or I say through loosely, you know what I mean, running along a piece of matter, call it a copper pipe, or a copper wire, right? You have a certain energy density that exists in that frequency as it's propagating along that path. Okay. Now, once you start bringing these wires closer and closer together, the waveform interference starts to occur. Okay. And at different distances exist different densities. And at different densities exist different constructive and deconstructive interference that occurs, that ultimately is the causal manifestation of different electromagnetic densities and therefore properties. So nothing, right? Static, plasma, spark gap, because now you're arcing.
Yeah.
And then if you bring it together and it's touching, then you get the purest form of interference, whether it's constructive or deconstructive, depending on the resonance and the geometries, okay, that could possibly exist for that particular system, given the system itself and the native input frequencies. That's the whole idea.
So he says we should build some cool crystals, and that's what we're going to do. Joe and I have been talking about this for a couple of weeks, and
yeah, we've been talking about it.
Time.
I got some Epsom salt. I'm on board.
Yeah. So I got a bunch of tools to put in there, man, to make the frequencies and stuff, along with just a basic frequency generator. We can run it low power. You know what I mean?
Yep.
So I'm interested in the simple fact of it. Like, I want to know when we get that.
Can I make a suggestion? I'm sorry, before we move on from that. So when inputting a frequency, it's just my general suggestion that you and I talk sidebar about a way to free float what it is with a damper. So you have a damper and then like a line or something like that, and then have it free float and then input the frequency there. That way you could reduce the ambient frequencies as much as possible. And frankly, it'd probably be best if it were done in some sort of pseudo Faraday cage. And maybe that's something as simple as just like some chicken wire wrapped around it, with some tinfoil. Like, I just off the top of my head, but I just had that thought, so I figured I'd throw it in there.
Okay, do you think so? Let me ask you this: do you think light's going to be part of it in doing this? Because if you just did it in tinfoil and put like a tinfoil hat over the whole thing and just had the wire going in, do you think the light itself is contributing to the building of the crystal?
I mean, light is radiation, and that's resonance. I mean, not resonance. That's a waveform. So I think that.
Are you trying to isolate that out?
I think you isolate every variable out the most you can to get your best result.
Okay.
So, dark, suspended, dampered, EMF protected, and then straight. Like, I think that's the scientific method for that, personally. The best you can. Nobody here has laboratories like dedicated. So
no, but
you do the best you can.
A simple tinfoil over the whole thing would stop any frequencies from the outside from getting in, and then whatever's in there is going to grow. So my only question was light going to affect the growth rate of this thing that we don't take into consideration when we look at these videos? That was my only concern.
Yeah, no, that's true. Listen, a lead box would probably be ideal, but you work with what you got. That'd take a long time. It's hard to evaporate shit into crystals when the water has nowhere to go.
Yeah.
I mean, it'll happen, but it'll take a long time.
Well, also the amount of energy in there is going to be less because we don't look at the light, but the light creates heat at certain parts of the day, and then at certain parts of the day the heat goes away. So it's you'll have to probably do one in the light and one out of the light in order to see what the differences are. I'm curious to see, because we just talked about water heating up and then giving off energy. You know what I mean?
Mm-hmm.
So I guess it's all factors in how you look at it, right? And then how much crystal you're trying to grow and what are you trying to do with it? So what I'm looking at is just, if we took this little piece of tiny crystal, in your fingers there, and we just grow it maybe this long, just to see how it works. You know what I mean? Then you could grow bigger and bigger crystals. But I think as a general idea, just to start off, a little one would be all right.
Well, one thing interesting to think about too, it's not that deep of a thought, but if you think about like stalactites and stalagmites, and the idea being that you have dissolved minerals drip, 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 and then over time the dissolved minerals accumulating, and being left behind through the drip process, right?
Mm-hmm.
But I think that it's just easy at this very basic level to understand, oh, okay, so it's got dissolved sediment and it leaves a little behind, and that's what causes it. But have you ever taken the next step to think about, but why does it leave it behind? Right? Why does it leave it behind? Well, it leaves it behind because it had a seed. The seed was in resonance. It made a deposit. And then that seed grew because every time that there's a dissolved solid in that liquid that's in resonance with it, it is left behind because it's in resonance with it.
Mm-hmm.
That's what it boils down to. And it's such a simple idea, but again, when you're taught this stuff at a very basic level in elementary school, it's like, oh, well, it's left behind. That makes sense. It leaves a little behind. You never ask yourself why it's left behind. It's in the water. It's been in the water since the water was traveling all through this. But at this point in time, at this exact moment, that's when it lost it and left it behind. It didn't leave it behind before. Like, that's why.
No, I get it. One thing I wanted to bring up, because I brought up the frequency. people bring up the 3, 6, and 9, right? You know why that's important? It's
Of course.
it's a I want to say this. It's an octave. So if I had 3, right, and then 3 plus 3 is 6, plus 3 is 9. So you have to take the original number, which is 3, and that gets added to the next number. Then that next number gets added by 3 again to make the next number. That's how the octaves work, right? So in any scale, it can be 55, and then it goes to 110, and then it goes to 165. You're still taking the original number and adding it to the next number, right?
Mm-hmm.
So that's why it's important when you look at the 3, 6, 9 and building these things out and the triangles and stuff, because they're creating octaves as you're doing the triangle itself. So when we're looking at the structure of it, that's why I asked about the different frequencies. Now, it could be almost like the frequency of A, but a different octaves of A. You get what I'm saying? So it could be you're creating a, like I was trying to say, from each one, the first one would be a half wave, the next one would be a third wave, you know what I mean? And go on, but it's still an A as it builds. But now we're just putting it in different frequencies and octaves. So
that's a great point.
Yeah, it's interesting because you may have the same main frequency in the beginning, but then it's going to build out over time. Well,
not to get super off topic on this, but I'll bring it up again. Stop using the metric system. Stop using it. Stop.
Well, you need fractions for this.
Root 10 is easy for the mind. It's easy for currency. It's garbage for understanding, natural law and order. Okay. 3, 6, 9. And then what is the next number in that sequence is 12. Okay. And there's 12 inches in a foot. Okay. It has nothing to do with how big an inch is or what constitutes what an inch is. It's how you break down what a foot is, and then how you further break down what an inch is broken down into: halves, quarters, eighths, sixteenths, 32nds, 64ths. Okay, it's these rational fractal patterns, okay, that exist in imperial measure, all right, that are wildly related to the ratios that exist in natural order. Okay, you have to understand this if you're going to start engineering shit that works, because working off of a root 10 is broken. And that's why Europe and Canada uses it, is because they're fucking broken too. Like America knew this, and guess who knew this too? The founding fathers, who measured in inches and feet, who are also Freemasons. And you have to remember something. In Fahrenheit, there's a reason that ice melts at 33 degrees. Okay? Like, wake up. That's it. Metric sucks. Fight me. It's easier, and it sucks. The easier isn't better.
No, it's like when they start messing with 432 to 440 in your frequencies, they screwed everything up. It doesn't matter if it's more appealing to your ear. I could give a, I care that it matters in how you build things out, because one's right and one's wrong, and one's destructive and one's constructive. And I don't have any, I don't really care. I don't want destructive. I want constructive all the time. I want to build things. It's important to understand it that way.
Yeah, if things aren't divisible by one another in, proportional type things, like this is where deconstructive interference occurs. Okay, period. Hard stop. End of story. All right. And deconstructive interference isn't necessarily a bad thing all the time, but that's if you want it. If you want constructive interference, you need to be, things need to be divisible.
All right, Joe, hold on.
Primes are where holy shit.
It's the frequency master right here.
What's going on?
Guys, I'm having a hard time setting up here. Like, all my shit's old and garbage. And no, it is, seriously. I just put curtains up with a coax cable.
So hold on, this is Cody Creative Studios, also known as Brendan.
That's right.
He's
Serving
been
up-
banned from this show. I don't know how he got on.
Yeah, right.
Fuck you, Joe.
You guys are terrible together.
I was all set up and now it's all screwed up. So here it is. You guys carry on. I'm gonna keep messing with stuff here.
Hmm.
I got a bad echo, like I'm streaming, and I'm hearing both things going on. So I don't know.
Well, brother, I must say you look fresh. I like your hat. Looks like you showered. This is good.
No.
None of that. Amen.
Give me a second here.
Yeah.
Oh,
Okay, I can hear you guys. I'm gonna switch. Oh my god. Keep talking.
oh, I can't wait, man. We might see that plasma TV take some more beating today.
Hey, yeah, I got it back there, but I didn't have time to set it up. Joe just dropped
Oh.
this on me like an asshole. So, like maybe 20
Alright.
minutes. I've never streamed before, so I'm just.
Oh, hold on. I'm gonna go ahead and then pull up what he does so everybody knows. We're
Yeah. I gotta turn that off. Connect this. 1 second, guys.
That's so cool.
yeah.
Oh my god. Now bear in mind, like this is after working all day and drumming and like this is just this pure hobby, right? I just play with it. And that's how I learn. Sounds pretty intense. 1 second.
Why don't you explain what's going on here, Brandon?
Oh, hold on. Hold on. Here we go.
I'm still
Let me-
working on my setup, dude. I'm just getting
You're working
the
on your setup
audio
to have to
right.
explain the video that you already made?
You explain it.
He's got his focus in another place.
All right, I love you. I love
Yeah,
you. Go do what you're doing.
I'm so fussy with audio stuff. Like I'm a sound Nazi. Everything else, I'm not. I don't.
You're not
really
allowed
do.
to say that, Brandon.
Oh, I'm sorry. See, I'm gonna get him in trouble. I told you this, Joe. I'm not fit for TV.
Look at that. The wood's actually moving when you put the electricity into it.
Yes, sir.
That's cool.
Now, can anybody explain that? Like, from what I
Yes.
understand, it's dielectric. Attraction, repulsion. I don't know.
It's my theory that you have an ambient charge that's actually being put to your sink, that's on, and then
That's
that's
right.
creating a
Signal
charge separation. That's then creating a repulsive force. That's what I think.
I think you could be right for a change.
Yeah, asshole.
I can hear you.
It's fine.
Are you guys getting any echo?
No, we're okay.
Not really. You're fine.
Okay, good. Perfect.
So what it is you're taking that piece of wood and you're saturating it with energy. And when you saturate it to energy, just like a static field, it'll pull and cling to things. And then as the energy shuts off, it releases. And you'll continuously do it. Yeah.
That's exactly what happened to you. Thank you.
It's like my rock, except wood.
I know, but
and hooked
like,
up to a power source.
didn't Tesla use wood as an insulator in a lot of his setups?
A lot of the setups had wood to it. Yes.
His tower construction, his transformers. I think he used it quite often as an insulator and construction material.
So let me ask you something. The pipes going in, are they copper or the metal that go into the actual sink?
It's totally okay. I'm renovating the camp here. It's totally isolated earth ground, and it's just connected by a wire.
Okay. But so none of the pipes and everything go into the ground at all. So, okay.
No, nothing. Everything that is grounded is my own ground that I put in. I put in an 8 foot piece of 1/2 inch copper pipe. It's not like a mains ground.
Yeah. I I think it's more of the, yeah, like you're saying, that's the static field pushing on it than it is an electric. Well, I shouldn't say that. Static field is just a low magnetic field in there. Then you can bring up the magnetic field, and then, you know what I mean, obviously it changes. So you have like a low amp field going on there.
Yeah, like a high density charge separation.
It was.
If you want to be fancy about it, yeah.
Sure.
I think that's the flyback setup, and it was just a 23 watt CFL as a driver. I was actually trying to make a high voltage power supply for Jarvis.
Oh, well, you're using a flyback, then absolutely you got that going on. So you have very little amps and very high volts.
Right.
Absolutely, yeah, that's exactly what's going on.
Yeah,
It was
moving
totally-
lots of flow.
It was the last thing I did that night. I was ready to fall asleep, man. I was like, one more try. I just put a screw in the wood and hooked it up. And I'm like, what the fuck? I mean, the thing's moving. It was actually pivoting on a cup in the wood.
Mm-hmm.
I got all excited. I'm like, what? Okay. I thought about it for a minute.
I'm gonna expose Brandon for a second. He does some really, really cool and interesting stuff just with wood generally. Trying to, make surface levels of like graphene nanoparticles, and then
You mean try-
making cells out of them. And he's getting good charge off of them, especially for what they are, which is awesome.
What do you mean trying, Joe?
I'm not saying trying. You did it. I've seen it. That's what I'm saying. I'm saying that you're experimenting with. I'm sorry to use the word trying.
I wanted to
But
give it
I guess
a
that implies failure.
all my chat brothers are like G Jabber, Yuli, His Highness, all these guys that I torment and chat with, and just wanted to say hi. You guys are like my electro bros. I love it.
Give me 1 second. I'm going to look up real quick because he has. He was playing with a washing machine motor a while back.
That's actually a Samsung Smart Drive.
Yeah.
That thing
Sorry.
was wild, man. You can get a lot of power out of that. If anybody's interested in running a small, excuse me, a small scale wind turbine or water wheel or whatever.
I'm almost there. Sorry. Just give me a second.
Yeah, I can grab it. It's right here.
Takes a while to go through the pictures, man, and some of the stuff's not appropriate for TV.
Right. Nathan, you should really give me the down low on what we can and can't say too, because I'm terrible. Are you still there?
Yeah, this is what we're talking about right here. So you connected it through a capacitor, and now you're arcing it, right?
That was like the first test, just to see if I could get anything out of the 3-phase, because it's actually a high frequency 3-phase that comes out of it. And I didn't really have a clue of what I was doing. I had somewhat of a clue, but just trying different things, man. Trial and error. I'm no genius. Clearly.
Yeah, so let's see if it's this one right here.
I don't know, man. You had me fooled. I thought you were pretty on point.
Now he's kissing my ass because he's scared I'm going to roast him live.
Oh, kiss my ass, bro. I'll show everybody the picture. You know which one I'm talking about.
Don't even go there, Joe. I know better.
Hey, Joe.
Hold on. Trying to see where the sparks were.
Okay, that's one of them.
This is one of them?
Yeah, but it's sort of an evolutionary process. I sent you a couple of videos of just
Well, there's your spark. There we go.
how I came to that. But it was like those UPS backup power systems?
Uh-huh.
I had taken parts of those. They had some nice big juicy blue super caps, right? And I just wired them up in parallel. I took 2 bridge rectifiers out of old generator parts, like 250 amp bridge rectifiers, ran the 3-phase in parallel rectifiers to the cat bank, then to a spark gap. I forget. I hit it so many different ways. I was just trying, right?
Oh yeah,
But I
well
did-
I understand that.
Nathan, can you translate? I don't understand Canadian.
You asshole.
Oh no, he's converting the potential into a DC, and then he converts it again to an AC, and then he's lighting it up.
Man, it one revolution of that motor, it made enough. When I shorted the cat bank, it would stick the screwdriver to the cat bank. It was insane.
Yeah,
Then it started. Then I asked you about like it started to make me sick. I started to not feel well, and I know we can't go there, but
Yeah, well, it has the ability to do that with what it throws off. So understood.
it was a high capacitive, high voltage. I was using actually an ignition coil from a vehicle.
Oh, in one of those coils, let me see if I got this right. You have to take one side of it, and it's the anode, and then the other side is the cathode that comes to the center part of it, and you can get a spark coming out of it with a basic 12-volt input. So it's got like a primary and secondary system, just like a flyback.
Yes, right. But I was running 200 volts on the primary.
Right.
3,000
Quite a bit different, yes. No, not 12.
3,000 microfarads and 200 volts would discharge at one revolution for the motor with one finger.
Wow.
And man, it was scary. Like if you don't want to accidentally hit yourself with this thing.
I was gonna say, I hope you have like an auto send obituary going on, bro, because like
Right.
that shit dangerous.
Well, I do it half asleep, so it's safe.
Fair.
Yeah, those motors are nice. The magnets on them are about a 1/4 inch thick, and they're slightly curved. And then the amount of copper on there, it's like a what do I want to call it? Like a 12 gauge, I think it is, copper wire, maybe a 14, but it's real heavy duty copper on there. So you're
Yes.
getting mass energy pulled out of there every time it goes around, and it weighs a lot. So you know that the metal in there, the soft iron plates, is quite a bit. And it's about, say, that thick, so about an inch thick at least. So you get mass energy pulled out of the thing with that drill hook to it.
I'm talking to even just spinning it with my one finger. I could get enough power and enough bang out of it, like it would just my ears would be ringing for hours.
Yeah, oh yeah.
Right.
Yeah, that
and
thing
then-
was loud, man. I remember when you were toying with that. The thing was loud.
They're very reliable and durable motor. I can tell you that. They're actually rated. They're made to be ran off an inverter at 300 volts, 3-phase.
Yeah, I remember we all watched who was it that did all that? I'm trying to think of his name right now. He did all kinds of stuff with those motors.
Heliarch. Was
Yeah,
it?
not the one. I was thinking Gerard Morin. Gerard
Oh
Morin.
yes, that's how I started.
Yeah.
With a small pump motor. Yeah. Watching you.
Yeah,
guys.
just they're off front loading washing machines. So it's just a drum motor. You pick them up on eBay for about $50 is where I bought mine when I did it.
Really.
And yeah, and that thing, man, it cranked it out. The hard thing is you're over there trying to take this thing like Gerard did, and you're trying to take a RC car switch, right? The 3-phase on it, and run it like a brushless DC motor is what he was doing, which is an interesting setup in itself. You're just basically throwing a pulse wave into each one, and you have to have sensors to be able to tell you where the motor is in configuration to the magnet at all time in order for that thing to work right.
Maybe somebody in the comments can pipe up on that because I didn't have a
Yeah,
clue.
V-Fed.
The Hallback sensors on the motor. I just bypassed it. I put a mechanical switch, which that's cool too. But it worked, right? Make and break, one revolution. I can up the frequency by adding 2 switches. If a
There you
switch
go.
breaks, throw it away, change it. Right? I have lots of them.
Simple conversion if you understand motors. If you don't, it's kind of hard. You know what I mean? So a lot of people didn't understand that, and they buy this motor and they go, oh, "We have no idea what the sensors are, but we can't get it to run." You know what I mean? Because you're not activating the sensors, and it's meant to be run.
Did Gerard Moore, like, I heard different people say that he scammed them. Like, is that true, or does anyone know in the comments? Or
From what I understand, man, I don't think he sold any devices. I think he did research on it, but I don't think he sold anything. I've never seen anything about it. Like, I saw one time somebody complained something, and then you see Gerard the next day come on and say, "What did I do to you? What did I sell to you?" You know what I mean? Stuff like that. And it's like, well, did he sell them anything? Like, what are you going to sell him? A motor that you could buy every day off the shelf? I don't understand what he's trying to sell him. You know what I mean?
Well, I mean, honestly, that would be the opportunistic like thing to do for someone who caught on to the idea of that, is just to rebrand something that already exists as basically running in reverse or whatever, you know?
Yeah, it made no sense. But to run these things as a generator makes all the sense in the world. And the whole thing is your input motor has to be small enough in voltage, but high enough in torque and value to push that thing in order to get a different value. You know what I mean? You can't have a 1-to-1. It literally has to be maybe like an 8 to 1 in order to get the conversion right, in order to pull more out. So it's like taking a DC motor, a little motor for your RC car, and trying to run that generator, which basically is what your drill does. It just has gearing in it to make it easier. So is the conversion easy? Yeah. If you understand, rates and how they work with gearing, it's fairly easy to pull motor out of that motor.
The thing is, I've seen a lot of guys modifying the stators, and there's absolutely no need of it if you can just manipulate the energy coming out of it as 3-phase. Bro, why would you want to load up the motor with trying to pull amps out when you got 3-phase high voltage that you can split, and you can drive whatever you want. You can fill a cap bank, which makes it even easier. Like, I had, after a discharge, I had a surplus of energy left in the caps.
Yeah. So think about it this way: your normal drill, you can run them from anywhere from 12 to 24 volts, right? And what you're pulling out of that thing is more than 100 volts of electricity, and you're pulling amps out of it like crazy because of the size of the wire. So converting that over to a loop system, it's fairly easy, and you could pull probably at least 40 more volts out of it than you can, you know what I mean, and what you're putting in. So
what's more free than the wind? It's always windy here. I'm in Cape Breton Island, and it's just constantly gusty, blistery winds. So that thing would make power all day long, right?
Oh yeah.
Free
at a slower rate, yeah, but if you're filling a capacitor bank, then it'd be fine.
I know what you're saying. Yeah, you're. It seems to me I've never played with a motor that I didn't get that back EMF and that cogging, that magnetic, I don't know what you call it, but back EMF, is that correct?
Yeah. So create a spark gap and stop it. You know what I mean? So normally when you deal with something like that and you want to eliminate the back EMF or the resistance in the motor, you have to run it in a cold format first. So if you hook it up to your MOSFET and you run them backwards through the negative, then it'll go through the motor and it'll pull and flip that dielectric field to the inside. Now that it's in the inside, no matter how much you turn it, you won't have any eddy current going on, but it'll spin freely and fast. That's the whole catch. You have to be able to convert it first into cold energy. Once you move the dielectric around, now you can build energy in your system continuously on all the rest.
Right. So not worry about the waste and the friction and all that stuff. You do away with it.
Yeah, Mike knows all about it.
Right.
Yeah. That's kind of the secret of this whole thing is you have to be able to flip that field first. If you don't, then you're just going to get a bunch of cogging, and it's horrible. Like Mike deals in a pulse motor, right? So you pulse it once, and then it goes around, and the rest of the coils pull in.
Yep.
So
It's
yeah, it's
pretty
kind of
wild.
one of the secrets of free energy. There, if you could understand what I told you, then it's a secret to free energy right there.
If here's my dilemma. Like if I'm running this thing and I'm pulsing, I'm making a massive like magnetic field bubble. Like as you said, is there any danger to my electronics or things outside or anything around it? Is that gonna? I don't know.
It's the amount of frequency that gets put out in your room, depending on where that is.
Well, 30 feet away, it was setting off the computer. So,
Got some reach.
You got some reach.
wasn't
Hey, don't feel like you're the only one, man. I run my Gravity Flyer. My computer absolutely hates it. Turns on, you know what I mean? Starts blinking and turning on different web pages and everything else.
Oh, jeez.
You're actually saturating the MOSFETs themselves. So you're causing a saturation inside of them in order to turn the switch on and off. That's exactly what you're doing. Now, if you knew the value and frequency of each one of them, then you can turn off certain ones just by changing your frequency that goes into them. So if you knew which one turned on the page for Google, you can flip it up and down all you want.
No way.
Yeah.
That's craziness, man.
Frequency is a mean machine.
All right, guys. I now that we have Brandon on here, I think this is a great question to ask. And I had posed the question to Nathan earlier. He didn't respond, so I think it's fresh. Okay.
Okay.
All right. If you have frequency propagation, okay, that enters into a time dilation field, okay, that's different from its point of emission. Okay, what happens to that frequency waveform as it goes through that time dilation field, and does it and how does it exit?
Frequency through a time dilation field, and how does it exit?
Right. So you have a source of frequency emission and propagation. You have a time dilation field differential. Okay. With it, obviously, as we've discussed before, being a diffuse gradient with the greatest, dilation in the center. And then you have this transmission running through that time dilation field. So what's the effect of that waveform as it goes through the gradient of the time dilation field? And how does it, and in what form does it exit that time dilation field?
So
relative to inside and outside. See what I mean? Because that's the other variable too.
okay, so if I took this picture right here, right, and I put the value in the center as my whole field, right, and then each time it goes through, it's like your octave. It, you know what I mean? It changes it. So is it now a half wave? Is it a quarter wave? You know what I mean? Is it a third? That's what it would do going out. It would change the actual frequency itself. Now, I think inside the frequency would be lower, and then it'll get to higher and higher frequencies as it comes out. Because each level you go to it, so if you just took each one of these spheres and you said that's your time dilation field, right? Then you'd be breaking it into different frequencies as you go, but it'd be in the same frequency.
Cool. So now being outside of the time dilation field in the same realm of time dilation as the source of emissions, how could that be exploited in order to, have an increase in power? Do you see where I'm going with this?
Mm-hmm.
My brain hurts.
So let me just say it this way. In this device, I would take the inside right there and the first round sphere and the center where you see the little round ball, that'd be the anode and cathode, and from there the energy would build out. So the hope is you get enough magnetic field built out so that you can create your bubble on the outside, right? Now, that inherently would have more energy on the outside than it did on the inside once you're done because of the surface volume of the entire thing. So if I say the volume on each sphere is multiplied by the magnets that are put on it to keep them evenly spaced, then the outside energy would inherently have more.
Exactly. So what happens when you then extract from the center of that time dilation field only the excess accumulation that occurs through the time dilation, and then it's allowed to be emitted through? Then you've now extracted an excess energy from it without necessarily affecting the waveform.
Well, it's the well that never runs dry, isn't it?
Right. That's exactly it. And the reason I bring it up is because I put it in this abstract, but that's exactly what we're talking about all the time when we talk about the center compression null zone of extraction. That's exactly what it is. It's just this example of it goes back right down to time dilation.
Yeah,
as being a mechanism of why you could extract that.
Go ahead, Brendan.
Well, what I'm envisioning is the Earth and the Birkeland currents coming into the solar system. What's going on in my head when Joe's explaining this? I'm trying to just envision, and I think this is what's going on in the Earth's magnetic field, and the planets and the sun and everything. Right? What you have in this diagram is probably a scaled version of that.
Oh yeah.
Right? Oh, absolutely.
Mm-hmm. So my thought is, though, what if now the center of it, instead of a conventional field with magnets, now what if I put a radiant field in there? Now I'm going to push through every single layer of this whole device to go to the outside. But for every single time it goes through something, it has to interact with it. So I'm going to get a back EMF through any part of it if I make it out of a metal. So if I simply said, I'm going to take each sphere, I'm going to make it out of plastic, then I'm going to go over and I'm going to take aluminum or copper tape and tape every single one of them, but then I'm going to run radiant energy to act like a gas that pushes out, right? Now I can multiply that energy even more, right? Because I'm picking up energy on each field, and every time I spin each part of that energy, it's going to build more energy out, right? So if I just gear this thing properly and do that, I should have a gravity drive.
Yeah. I'd imagine that.
What you just said happens in nature as well. If you look at sprites.
Oh, it does.
Huge thunderstorms that emit these basically gamma ray bursts that come out of the top of these thunderheads, right? These massive thunderstorms. We call them sprites, I guess, right? It's relatively new and not well understood phenomenon, but it's creating, beyond the Earth's field, it's creating a pulse of gamma radiation.
So I was thinking of doing this in, like I said, a 3D print the plastics. I'll look at it and decide how much gearing I want into it. So at each level, we'll put a gear and a bearing. So top would have a gear and a bearing, and then the bottom would just have a bearing. And then we'll rotate them, right? We should be able to pull out a ton of energy, especially because the energy that comes from the center of the Tesla coil is a radiant energy. So it's going to push through every single one of these spheres, no matter how much you put on there. You can put aluminum foil on there. You can put aluminum tape. You can put whatever you want. It's going to push right through it, okay? Because it acts like a gas. So now all I'm doing is picking up those extra energy. So should I put magnetic fields in it to amplify it at that point? I guess that would be phase 2 of it. But phase 1 would just simply be the tape and see what it does. I think we can make gravity out of something like this if we can. There's an application for it in space.
Where did you find this?
Sure.
Where did you find this diagram?
oh, somebody had it on Facebook, and I said, oh, you know what I mean? It just popped up when I scrolled through. And I go, I gotta have that because I gotta try it.
Is
So-
anyone tokamak? Is that what it's called? The cold fusion reactor, tokamak.
Hmm.
It just
I don't know
reminds
anything
me-
about it.
Yeah,
Is
no,
that
I
what it
never
looks
heard of
like?
that.
You never heard of that massive energy sucking supposed cold fusion thing that probably uses more energy than it gives out? Huge
Well, that's
mag-
probably why I didn't pay it any attention if that's the case, because that sounds.
it's
Yeah.
it's supposedly on the it's in the forefront of this technology, and they're close to cold fusion. Tokamak.
Interesting.
Chat, ask the chat. These guys would know.
So
Smart guy.
here's another, here's another little mind bender, right? And this goes to show about the relationship of matter in the solar system and galaxy and universe and space just generally. But when you step out of the thought of this whole planetary system of shit orbiting, and it's just like this round thing and whatever, we're also in this galaxy that's also doing the same thing, right? And then like so on, right?
Mhm.
And we know that that's not really what it is. It's like an ongoing chase. So you have like the sun kind of leading the way, and then everything else is just tearing ass or behind it, more like a helical than anything. So it's almost like our solar system is like a cone tube of orbit, like kind of chasing the sun in this helical fashion. That's sort of more accurately representative of what the solar system is, right? So when you think about interplanetary travel, or even just something as simple as travel from here to the moon, right? It's not like, okay, well, we're here or there. When you're in between and you're in this chase, and this chase is occurring at such a high rate of speed, the fact that you're not getting, like, as soon as you exit this proximity and you're in zero gravity at that point, right? That everything isn't blowing right by you because you're not traveling that fast. So the same as like a person on a train, like you might be sitting still, but you're relatively going 70 miles per hour on this train or whatever, right? It's
Special
the same
law of
sort of deal when
relativity.
you're in space. Like you're going along with it, like to a certain extent. Like, yeah, you still have to deal with trajectories and different things. But if you were just to exit into the space and then all of a sudden, you're moving whatever speed you're going, everything would pass right by you if you weren't still relative to it, right? So that's how you know that there's fabric, and that's what's important to realize.
No, you didn't go there, Joe. Not Einstein. Not relativity.
Yeah, he did.
Well,
law of relativity. He went right there.
Relativity's not dead. Relativity's a real thing. Like
No, I
it doesn't.
agree.
Yeah, if Einstein got anything right, it was relativity, because the measures aren't all the same. And when you exit Earth's atmosphere and you're not in a lock orbit like a satellite, and you're in between point A, point B, if you're if you're not under acceleration and you're in a plane of stagnation, then everything should just technically blow right by you, but that's not really it. At that point, you're in the ocean of the solar system. You're going with the flow of the ocean of the solar system at that point.
that makes sense. That makes sense. We don't need relativity, though. I mean, he did have that right. We have to give him some credit. Einstein looked at things differently, and he supposedly copied different works, but who hasn't? He's building on, the backs of other people. So,
no matter what comes of physics, I think relativity is there to stay, because all relativity realistically is the idea that everything, all measures are based on perspective of their environmental circumstances. Is really realistically what it is.
All right, guys, I got another one to show you.
All nature is a coaxial circuit to dance between the dielectric and magnetic. G-jabber.
So check it out. We're looking at the Gray tube, right? Edwin Gray. is a bit different, but it kind of, like I said, it's a radiant field. It passes through everything. Now, what if I took my high voltage DC and just connected it to the third layer out, right? I can transfer that energy from cold to hot throughout the entire thing right away.
That makes sense.
It,
That,
it,
that looks like an electrolysis cell, is it?
it's a guy that took a can and started making things with cool materials. I just thought it looked totally awesome versus what I wanted to do in the first place. I didn't need the bottom of the can, mind you.
Yeah.
But
I know in electrolysis cells, that looks like a Joe cell. Does that ring a bell, anyone? Chat, people? Joe
it a
cell? Has
cricket?
anyone seen Joe cell?
Joe cell?
Yeah.
Well, I guess he would have to put the cell part into it. This is just the shell of it. I wasn't sure what he was trying to make. I just looked at it and said that's exactly how I wanted to make my gray tube.
It's not to say that it wouldn't work in your application. Eighth Sitter says it's a Joe cell. I have those same containers. Use them, man.
Yeah, there you go.
We never going back to. I'm reading comments. I'm sorry.
It's a Joe cell. Yeah, okay.
The comments, the chat rather, they know a lot. I learn a lot from here.
Oh yeah, I agree.
Yeah. So what do you intend to do with this, Nathan?
Well, what I want to do, like I said, I want to use that Tesla coil energy, and I want it to build out in a radiant field. It's going to pass through every one of these things without a problem. I want to trigger it. So usually, in order to create the hot field out of the cold side of it, you have to be able to flip it. So simply put, if I took the rod down the center and I added a bigger rod around it and I dropped it down in there, it convert my field. Because automatically I came too close to the outside windings of my Tesla coil, which would make it hot. Now, the idea was to make it cold by putting the rod down the center at a very thin level, in order to do it. But knowing that all I needed to do was move the diameter of it in order to change the heat in it, now I can look at it in a different way and say, if I now take a DC flyback, which puts out a lot of amps in it, depending on which one you get, now I can convert just based on heat. Now I can just heat one of these suckers up in a minute. You know what I mean? And boom, pull that whole field and change the entire dielectric of it to pull outside instead of inside. And automatically I have enough power. Now I have amps. Now I can run motors with it. You know what I mean? That's the whole point. And then when I let off of the DC flyback, it goes back to cold. So now it's just cycling as the motor goes, right? And now I can pull off the back EMF in order to charge the capacitor. You see what I'm saying? And I just go back and forth and how I drive.
I've seen that same effect in the smart drive. Yeah.
Just interesting.
Well, my smart drive set up with what we talked about before, it would just collect energy on its own from the ambient field. It would just, I shocked the hell out of myself. I grabbed the plasma TV. It was hooked to the cat bank. It was discharged. Switch was engaged, which means the primary was, there was 0 volts. The next day I went to grab the thing and I just, it lit me up. Gave me a wicked shock. I dropped the fucking TV and I'm like, oh, did I smash it? Oh, how did this TV survive? I have no idea. But it's still going.
I might have to zap me a TV. I got one sitting outside.
I wish I could send you one, but they weigh about fucking 150 pounds. I don't know.
Oh, no, I got a couple, man. Let me tell you, my kids keep moving, so I get the collection of everything. You know what I mean? Sometimes, oh, no, I got a newer TV and it's smart. Okay, well, I'll take the dumb one. I don't care. It's just sitting on my wall.
Take the dumb TV.
Yeah.
What do you think, Joe? You're pretty quiet, man.
Yeah, well, I'm listening and absorbing. I get to learn sometimes too.
I like listening to Joe.
Nah.
Oh, Jesus.
I'm telling you.
Hey, what, Joe, what was the line that in the song? Woo woo.
Whoop whoop.
No,
Sure.
what was your line in the song, Nate?
Damn, I forget, man. Joe talks to the woo woo.
Yeah.
we know that. I mean, listen, I don't deny it. I literally disclaim myself frequently.
Woo woo. Joe and I think very similarly. He's a bassist. I'm a drummer, musician. Bassist and drummer usually keep each other in check. It's kind of a weird phenomenon.
Yeah. I play bass exactly like I think, which is I just go way off track most of the time.
Little out there, Joe.
Yeah.
Just checking out some comments. Adams, wait.
Well, hold on. I found something that might interest you guys along the same lines that we were just looking at.
I'm getting a big time delay in what I'm seeing. I'm watching the stream on my plasma TV, and I don't know. It's like super laggy.
Yeah, there's a YouTube delay, from StreamYard. So if you watch it through StreamYard, you'll be seamless. But if you watch it through YouTube, you're going to be a few seconds behind.
Yeah.
Okay, thanks.
So check this thing out. It's just like what we were just talking about. It's a sphere inside of a sphere. You know what I mean? Like a Russian nesting doll.
Yep.
Dude.
But they're looking at it for anti-gravity, which would obviously, if you create gravity, you might have anti-gravity, right?
Looks like my dome, man. That's a 3V frequency.
It does look like your dome. It really does.
Yeah.
Now you're talking.
Well, of course, this would play right in line with anti-gravity because each layer is a pressure differential. Every time there's a differential, there's going to be interfield torsions. Every time there's interfield one thing plays to the next when it comes to the layering. And I think what's important to understand about this is that because they work both independently, each layer of it works independently of another, but in conjunction with the other. That's the exact thing that upper dimensionality is. And that's what you have to understand. This is a higher dimensionality field interaction that's occurring. Yeah.
I got a question for you. I always talk about the double energy, right? To create something. What if I simply took the positive part of the Tesla coil in something like this and set it up in the center on one side? And then I took the negative part and set it up in the center on the inside, with both of them going off intermittently. 1, 2, 1, 2, at a very high frequency. That should create my pulse fields, right?
Pulse field, definitely. That's without a doubt.
So I wouldn't have to change the outside spheres. There could just be, one layer on each one of them. But then the inside is where the magic happens because it's going back and forth.
Now
it's
remember,
180 degree out of phase.
Right. Now remember, if you then bring geometry into the equation and you have them counter-rotational and counter angular to one another, you would have dueling vortexes at that point where the pulses ultimately interact would be an event horizon plane.
Just a comment. This is a weird thing I noticed while I was building the dome. If I stood exactly in the center, like I couldn't get Wi-Fi outside here. I have it all jerry-rigged for my brothers, and when I stood in the center of that dome, I would get like 4 or 5 bars of Wi-Fi on 5G. Normally, I wouldn't get anything. So something was going on with the geometry of the structure.
Nice.
Yeah, it's acting as like a condensation point, which frankly, domes are pretty good at. I mean, my understanding is that cones are even better.
Could be so.
So give me
You
a
should put
second.
spikes on it.
I'm
Those
gonna
are
pull
fun.
this up real quick. I'm gonna show.
Good point,
Kinda-
G Jabber.
Mm,
Knowing atoms and elastic fluids.
There's the inside of the dome right there that he's talking about.
Oh yeah.
So you see all the triangles in there and all the.
Yeah, dead center would I just suddenly you'd have nothing and then you'd have 4 bars of Wi-Fi. 4 to 5. What?
That's
Now-
cool.
The structure of this being made out of the triangles and then creating a dome is actually a hexagonal, the same as a hexagonal crystal structure.
Mhm.
Okay, and you know,
yeah.
yeah, it's the same as a hexagonal crystal structure. And when you build it out, it's the same thing. This is how this is. You know, it just goes with it's perfect geometry is what it is, and it's right in tune with the whole 369 theories as well. If you count all the triangles as they go around from the inner hexagon and then the outer hexagon and stuff like that, you'll start to see that very quick and realize that you're dealing with three-sided shapes that are creating 6-sided shapes that'll have 9 points at some point. Like, it goes right along with that whole thing.
That's how you increase the frequency. They call it the frequency of the dome. This is 2V.
Yeah. When you're dealing with the angles that you have to build all of those triangles out to form a dome at, I don't know, Brandon would probably have a much better idea than I would as to what those exact outward angles are. But I would bet you that they directly coincide with sacred geometry and fractal math.
Oh, yeah.
Absolutely, 100%. It's all sacred geometry and fractal math. And I studied that a little bit prior to building this, but I really started understanding it when I started putting it together. And when you make a little mistake, let me tell you, you learn because you got to take it all back apart.
Oh, 100%. You can't make a
Yeah,
mistake.
you're off a few degrees on this. It'll never meet.
Nope.
It's within it's what is it? A decimal point. Like you have to be very accurate with
Yeah.
your angles. I think it was like 9.1, 7.2. You got to be pretty close on your cuts. So, or it doesn't work. And there's both tension and what's the other force, Joe? There's
Sorry, potential and what?
There's both. What's the words to describe tension and the frame is under both tension
And tension and compression.
Yeah, I think so because I had to pull that thing, tension and torsion, limited state. Yeah,
Torsion. Sure. I mean,
Yeah.
well, there would be torsion if you're pulling it inward. There would be
I had to
when
pull
you
it
join it, it would be torsion. When you have the two forces, working against each other, but they meet, you'd have torsion.
G-jabber potential differentials. Yeah, exactly. You have two polarized forces. That's what.
Now, what's interesting is that there would actually be almost no tension and almost no torsion if the accuracy of the tolerances are precise, because at that point it would just be in a state of pure equilibrium. So get your head around that one for a second.
Dude, it's so strong. I built a scale model using small little lats, just leftover scrap from our mill. And you've seen it, Joe, right? I call it the Orton Cliff woodshed.
For real.
I put
Yeah.
it on top of the woodshed, right? But that thing is insanely strong. I jumped on it. I threw it around with Putin, the tractor grapple. It's just insane.
Yeah. No, it really is.
It's modeled after the carbon structure, a buckyball or a hexagonal, carbon atom Graphene. Right? I guess.
Yeah. Well, limited state says imbalance is necessary. 100% can't have equilibrium. I mean, practically that's true, but getting as close to it as possible, is a thing too. And limiting the force differentials that exist in tension and torsion create larger differentials that could exist that it would be able to take under load and so on and so forth too. And honestly, what a shape like that does to the ambient energies that are in the area, no matter what it is just a super interesting thing to think too. And there's so many variables in that it would be very hard to measure. But everything from like solar energy and how the sun just hitting into one specific direction and how that radiant energy goes through even the wood and then ultimately coalesces it'll coalesce at a very specific and certain point within that dome. I could guarantee you that. It's just that you have so many variables, it becomes difficult to quantify, and measure in a meaningful way. But that's not to say that it doesn't happen. That geometry is absolutely incredible. And even if you can't get it into some form of exact equilibrium, you're still exploiting the fact that it's as close to equilibrium as reasonably possible for a man-made thing, to still reap the benefits of being close to that equilibrium state. And anytime you're talking about crystal structures and natural formations and things like that we sing praises of for their abilities on this show constantly, right?
Mhm.
Like they're not made under perfect circumstances either, without variable that doesn't result in some sort of deformation of crystal structure at certain places throughout the crystal, like nothing is genuinely perfect, but the closer you get to that perfection is the closer to that you get. I mean, the closer to equilibrium that you get in any given system is your highest level of efficiency. That's what it comes down to. So, you don't need something to be 100% perfect and therefore 100% efficient in order for it to be much better or more efficient than something that is less so. Which is why that dome is going to stand up 10 times, or more, or whatever. I'm just using that arbitrarily, but like it's going to be more structurally sound 100% of the time than just a square box. That's what it boils down to. Or the way that it transmits different forms of energy or wavelengths, that's going to be different 100% of the time.
The structure carries it. It balances the forces with the more intersections, the more frequencies you add, the more it distributes the force, from what I understand. So it distributes it all equally along each section. So a 3V would be stronger yet. You could actually span more and more as you increase frequency, which is oddly very similar to what Nathan's doing with his fields, right?
Mm-hmm.
And you hit a harmonic, and it's gonna amplify.
Yeah, and genetic jabber's on point with the phase conjugation. I mean, that's exactly what it boils down to. And I mean, listen, I don't claim to know really anything, so I'm not trying to be like an authority on this and call you out on this, Tony. But like, yeah, if you're 1/1,000,000,000% off, it's still out, because out is out. I mean, you could say that day in, day out until you're blue in the face. But the fact is, the closer you get to it, the better the result is, and it's all relative. And you see that in resonance all the time when Nathan is doing his experiments. The closer he gets to resonance, the closer he gets to having really incredible outcomes of the system. When it's way off, then you don't get it. When it's closer, you get it much better. When it's almost dead on, you get the best result out of it. Is it ever perfectly in? No. If it's perfectly in, you'd open up a fucking portal and you could jump in the damn thing. And that's just what perfect equilibrium is. I'm bringing it to your attention and I'm calling you out on it now. That's what perfect equilibrium is. I don't think anybody's trying to open up a portal to outer space right now, so or whatever to another
I might.
dimension. So, like I think that for the purposes of what we're talking about, being within a couple hundredths of a percent of resonance is perfectly fine. And it's not to say that it's not relevant. You're not wrong.
Hey, Tony,
But
put it to him, man. Don't be scared.
Yeah. Hey, I might open a portal. Don't ever get me wrong. I might try.
hey, listen, if you can, you can. I mean, you get high enough power
Yeah, man.
differentials. Guess what? Your percentages of equilibrium go out the window because you have such a high density differential that all you got to do is widen the membrane of that differential, and there you go. There's your portal. That's what the portal is. It's that state of in between point A and point B that exists, and it always exists.
Would I then be a near Earth object? Like there's Fat Man Nathan in the space? You know what I mean? Like, how did he get by our space station? What happened to that? You know what I mean? He's got a frozen, stupid look on his face. Sorry.
Yeah. The full moon reflecting back like you're blind.
Yeah. I give him a full moon as I'm going by. You go, before I go to this portal, I'm dropping the drawers, man. There you go. I get the space station now. Hey, check this out real quick. I built this a while back for the wife.
Man,
Nice, man.
That I was blown away. That's incredible work.
Yeah. Hey, you might be retired, but your work is still nice.
I told Nathan my father was a cabinet maker, and it takes some serious precision to make that.
I made all the doors and everything too, so all from just scratch and put it all together.
That's awesome.
Yeah, man, it looks beautiful.
Jesus.
The wife was happy. I went ahead and put all the molding around the whole room, so it all matched it. So it just looks awesome, man.
I love that.
Nathan, did your father do finished carpentry as well?
Yeah.
Okay.
He was a general contractor and he owned a cabinet shop. So
really,
that's
wild, man.
Second generation cabinet maker. So everything looks nice and clean. Yeah.
I think that's how we all relate to one another, man. Like my great grandfather, my grandfather, my dad were all cabinet makers, and then I followed suit too, and just didn't do it professionally. I just did it for myself. It's awesome. It's the best thing to know in the world, because once you know how to properly build the box, there's nothing you can't do.
Right. Yeah. Because you still got all the clamps. Dude, I actually just cleaned out and sold my table saw, and I sold my compressors, and oh my God, the amount of tooling that I had is just astronomical.
Why?
Sold it all.
No.
Yeah, you were telling us about your dad's table saw and stuff, and
you gotta make that call, right? If you're gonna go all in on this channel, which I think is 100% worthwhile. Because it's
super funny that Tommy asked about the clamps, though, because I know from doing carpentry work, man, I get rid of any tool before I got rid of my clamps, because acquiring clamps is the biggest pain in the ass in the entire world, man.
Oh.
And you can never have enough of them and enough different, that's why I always like pipe clamps.
Yep. All of it, man. Well, also, one of the bigger things to me was my pocket cut machine. So I paid like $1,000 for one of these things, man. And you don't have to sit there with this little tiny tool and your screw drill. You throw the piece of wood on there, push it this way, and two routers go wah, wah, and it's done.
No.
And then you pocket cut everything together. It's a replacement for the dowel.
That's awesome. Did you have like the Festool one, or what'd you have?
Oh, it's professional. Yeah, dude. I was running things through this thing 100 miles an hour, man.
Yeah, those things are sick. I mean, they make life
all the way through it, and then
biscuits. That's the word.
Biscuit joiners. Yeah, I mean those are cool, but the Festool ones are cooler, man.
Yeah,
I like the pockets more than I like the biscuits. My brother liked the biscuits. I didn't. So.
Yeah, well, biscuits don't add any structural support to it. It's just an alignment tool, really, more than anything. With those pocket ones, though, like you could. It's mortise and tenon, for Christ's sakes. I mean, the thing's strong all day.
Well, not necessarily. It's just a screw. It's just a directional screw, right? No. You're thinking of dowels.
Oh,
So
you're
a
talking about
dowel.
pocket holes. Oh, like a Craig jig.
Yeah,
Yo,
except
I
for
mean, those things are great too.
industri-
Don't get me
no,
wrong,
no,
man.
no.
I cheat with those things all the time.
It's industrial. So you didn't
Ah,
have a drill and playing with this thing for hours with a little clamp. You threw it in the machine, locked it down, and then boom, boom, and you're through it. You know what I
oh,
mean?
that's awesome.
Oh yeah, 100 times faster.
What's it called again? What's the actual name of this thing? Is it
Uh, I guess yeah, it just says pocket machine on it,
Cool.
and it has 2 porta cable routers in it. Very small one, about this size, and then it's got the bigger one. So you're just going up at an angle and cutting it, and then it opens it up, and then the other one puts the hole for the screw on the other side.
Beautiful.
cool? Hey, I'm gonna
Yeah,
throw
no,
it-
pocket holes are strong, man. Like they really are. With especially if you're gonna still glue the joints and stuff. They're nice.
I'm gonna
Yeah, I've
give
done
it-
dovetails. Those are, together.
We
Those
could
things
talk-
I did for drawers.
we could talk about joiners all day. Back to what we're talking about, the plutonic solids. Nathan, what's the relation like with our? You guys were talking crystals earlier while I was fucking with my setup. Can we like tie that together? What relationship does that have? Your geometry and your energy. You guys can school me.
Geometry and the energy.
Well, I feel like the resonance has directly to do with the molecular structuring of the crystal formation, and because there's an input of resonant energy that is materializing at that point through that structure, that some of the attributes of the native frequency that is causing that crystalline structure to occur in the first place, is ultimately present in the end result of the crystalline structure itself.
Yeah, but it's one of the only things on Earth that performs the perfect geometry in every layer that it builds, right? So every layer is built the same exact way, and it could be off here and off here, but the actual structure itself and what you're making is exactly the same. So it's a pattern. So it's like one of the fundamental things in life. If you understand the pattern, you understand how it works and stuff like that, you'll always be able to create it. And that's what's exciting about it, because now you get into really the understand of geometry inside of a solar system when you start to build these things, because now you understand fundamental energies and geometry. So now building everything else becomes easy. It's like your first cabinet box that you make. Once you build it, you're good to go. Once you build one of these and understand how it works, now you got the secret to everything. Because I in no way think that there's giant molten balls, at the core of our Earth, nor do I think that the core of the sun. I think there's a frequency that's going on there in a certain way that excites everything else around it in order to boil it. That's what I think's going on. And I think it can't be all this hot iron everywhere for no reason. You can't just start a big fire in space. It doesn't work. You know what I mean? You just can't go out there and start torching crap, and it doesn't work. You had to build the sun some different way. Frequency builds energy.
It's nuclear fusion.
Well, I mean, a big idea with why there's molten metal beneath us, right? It really has to do with pressure. Again, like how do you keep something hot and in a molten state that should otherwise be cool and solid through entropy? You have to keep it under pressure, and you have to keep it under torsion. So like that lack of equilibrium that we were talking about before, that couple of whatever's of a percent, that differential is enough to maintain that process. If it was in a state of equilibrium, even under pressure, it would still enter into a negative entropy phase.
They're going to find one day that it's all lava tubes that this stuff goes through, and it's our ley lines, and we're starting to figure out that the whole thing is a big ball of geometry. And once they figure that out, and you have the lava tube, and then on the other side you have your water table, and those two counteract each other all day long, it's going to be very easy to map this whole place out.
I agree with that, Nathan. You got modulation points where the fields intersect, and you're going to have hot spots, right? Just like any.
Absolutely.
Yeah. And I think that
You want to find your hot spots. You should probably look for your iron deposits too.
Oh, 100%.
Look for your iron deposits. If you were to just look up Mindat, all of the iron hot spots, like mines and stuff, and you were just to light them up and then just draw lines in between them, you totally understand what's going on.
So hold on, that means that you're saying that there's not ancient civilizations that were built with iron and structure. So if you were to take Manhattan and melt it, okay, or New York, then what would you get? You get a big iron plate. You get a bunch of mineral deposits.
You
get a bunch of flaming liberals.
No, yeah, you get that too.
No, Nathan, what you're saying, I've observed in the rocks. You can see, carboniferous deposits of organics, where it's mineralized to hematite. So you have life converting to carbon. That's what I see.
Yeah, but life with life too. One of the main leave behinds of it is less so carbon, because the carbon can be released. Right. That's how you end up with CO2 through methane. Right. It goes to methane through decomposition, and then it gets released as a hydrocarbon that ultimately breaks down to CO2 and so on. Right. That's the hydrogen breakdown structure. But what's left is the calcium. Right. Most of the time, what's left is the calcium. Why? Because it's depleted.
Right. It fills in the void is what I meant. I don't mean you're left with carbon always. Depends on the circumstances. If it's buried. If it's on fire, a forest is on fire and it's buried in a flood, you're going to get, I would think you would get coal deposits and carbon deposits.
Well,
now I'm gonna tell you what happens when you have matter in equilibrium, okay, with each other in a system. You get trapped hydrogen, which is why this Earth is what it is and why it's populated, is because the hydrogen is trapped. That's why it's mostly in water and things of that nature, is because it's trapped. It needs to be relieved from that water state of equilibrium, okay, that exists. And not for anything, but water is as close to an earthly form of equilibrium that could potentially exist. That's why it's a solvent, to most things. That's why it's a solvent to most things. That's why it's ever present. But it could only really be as prevalent as it is here in a state of matter to energy equilibrium. Because once that equilibrium is screwed up and it goes one way or the other, okay, the first thing to go is anything hydrogen based. If it's energy, it's going to be hydrogen depletion. It's going to be rapid evaporation. Then it would be the separation of the oxygen and the hydrogen. It would be a fast burn, and then you'd be left with a long-term depletion of hydrogen.
Well, what I wonder, just kind of going back to the mineral thing, is if there was an advanced civilization and you had to press on your technology, you do it in stone, because stone doesn't work the same way. But iron drops back down to a deposit in the earth, just like Bernie does when he breaks chemicals down. He creates that red stuff that comes off the bottom and all that that goes back into the earth. So, just saying, it could reform in the earth, but it would generally just leave that deposit. And you'd be able to find it if you based it on that. Could you find an ancient civilization? You know what I mean? Did they leave some kind of stonework behind? Were they doing sculptures? Was there something else there? That's usually how they find them. And I don't buy that everything's a mud hut in the past. We had to evolve at least once or twice before we got here, right? The the first time.
We know that it wasn't all a mud hut. I mean, they were building stuff better than we do today, and we sit there and talk about how civilized we are. So I don't really know. Like, nothing that we build today, the way that we do it, is going to exist, 5,000 years from now. Like, that's not going to happen. We don't.
I'm going to go.
We don't build that same way.
I'm going to go a little out there and say I think that the Earth undergoes cyclical disaster cycles.
I agree.
Absolutely.
Most likely from the sun, and it seems to be, written in all the archaeological evidence. Miyake events in tree ring, in the fossilized tree rings through dendrochronology. There's so much evidence for it, and it seems to be about every 12,000 years. To me, that's what I personally observed and studied for a number of years now, and you can see it yourself if you go out and look at some rocks. Right?
Sure. Hey guys, I'm going to excuse myself for just like 1 minute. I'll be right back.
Okay. Yeah.
His girlfriend's
messaging him.
Yeah. Sorry, baby, I'm on live right now.
No, I think it's interesting because if you look at some of these other structures that were there, was there a structure there that created the society around it? And I think the pyramids are a good example of that. So like modern Egyptian culture is based around the pyramids being there. Or if you say Greek, you look at their big temples and stuff with the gigantic stones in it. Did that culture build it, or was it the culture before it that built it and you copied it? You know what I mean? Because they weren't building those again. They built different structures that look like them, but they weren't the same weight and size and everything else.
They built on the shoulders of giants as well. Like it was on top of much older civilizations, and it just, why wouldn't you? I think that these sites were strategically chosen for the fact that there was these converging magnetic field lines. They call them ley lines, I guess, but there's definitely some evidence supporting that. I'm not saying this or that.
If you wanted to build energy, wouldn't you want to find the place where there's more energy underneath?
Oh,
you know what I mean?
100%. Yeah, definitely. Now, whether they intuitively done this or just, like I find myself doing weird fucking things, man, just playing with energy, and I'll notice on my app, I'll get an alert for a solar storm. Like, oh, that's why I'm obsessing over this magnetite or this crystal. Like there's something going on in the field that triggers us being on the Earth and part of the Earth system. Activity, we'll say.
Yeah.
Don't have to
I agree with that.
Yeah. What drives us to do these things? What drives us to build pyramids or build domes or build coils? We have an intuitive, we're part of the system.
Definitely part of the system.
I just worry about the amount of energy to be created by those three pyramids. And if they had a fourth or whatever, what could you transform a planet based on the energy? That it doesn't stop for a lot of years. You know what I mean? We could have just been a water planet. Somebody shows up, starts building pyramids, and all of a sudden the water gets sucked back down. You know what I mean? It'd be the most interesting thing in the world.
How do you know they weren't? That was their purpose. Maybe it was the balance energy of the Earth.
Yeah.
If we have induction from the sun, like a huge amount of energy coming, more so than today, maybe that was their attempt to release that.
Yeah, could very well be. That's just the flip side of the coin that nobody really thinks about, because it's it's easier to look at something as an apparent like practical use than it is to figure out what problem it might have been trying to solve that isn't so evident to us at the surface level. Because the mind automatically sees the most practical and obvious application of something.
Is anyone in the chat familiar with Electric Universe? Obviously, some people must know this.
I mean, I am to a degree too. I don't really agree with it the way that it's presented, but
I don't agree with all of it. I don't agree with anything.
like I don't think right. I don't really buy the fact that there's present electrical charge and at any given place in space, because again, the electrical charge would be a manifestation of energy in the presence of matter. So unless if you have matter there to manifest it or something to measure it, which would be matter, right? Then technically speaking, like, I don't find it to really hold that much weight, albeit that you could probably try to detect such a thing like using waveforms and receiving a signal back from what you send, but there's no evidence of that. And again, in the absence of matter, if it's not manifest, then what's the difference? So I kind of see it as more of a sea of potential than anything.
So you don't believe in the ether, Joe?
I do believe in the ether, except it's not believe in the ether. I could say that based on the fundamentals of what I think is true, like I know that the ether exists, but the ether as a matter of, a potential, like it's like having a drop of water in a sea of water. Like, what's the difference at that point, right? It's not until there's a bubble in the water, doesn't matter, right? Or a rock in the water, doesn't matter. It's only that differential that makes the difference. So
Yes.
without any, a drop of water in the ocean doesn't matter.
So I was talking to Gerald the other day, and we were bringing up, what's that show that we were watching, Joe? Skinwalker Ranch.
Skinwalker,
Okay.
yeah, we were talking about that.
So when you look at it, you have magnetic field going on, and they pretty much said that everywhere. They keep going around and finding magnetic field. They're also finding beams that come out that are microwaves. There's also cracks going on around the surface, right? But they're also finding consistent frequency, the same frequency over and over and over again. So could it be a natural microwave in there? So you have a magnetron built into the earth that's a natural formation. And when you get those, and we were talking the other day, you take microwaves and cross them just like you would light, and you're going to get an EVO. So they may not be UFOs, but you may have EVOs flying around there. Now,
100%.
when I said that to Gerald, he said, well, are you sure there's just not a pyramid under the ground and we just don't know it? Like it got covered over time and it's still running. You know what I mean?
That'd be crazy to think.
Yeah, it blew my mind. I'm like, wow, I never thought there'd be a pyramid under there, but it's perfectly possible.
Here's just an analogy, or a thought experiment. If you could shrink yourself down and go inside of a capacitor, what would be going on there when you're blasting with high voltage? Like you'd see some crazy shit happening, right? You'd see air. I mean, not an electrolytic capacitor, obviously, but in our atmosphere, we're living in a capacitor. So there's going to be anomalous. I don't know what you call it, but Joe, what would you call it? Phenomenon.
Phenomena. Sure, yeah. Anomalous phenomena. Yeah, I think that's pretty par for the course for what you're describing.
Use your big words, Joe.
Well, not only that, we're running radio frequencies all over the earth where we didn't before. So am I surprised in any way that we're getting EVOs? No, not at all. It could be a malfunctioning tower that's starting to mess with stuff. You know what I mean? You just don't realize these things right away.
Well, that's a good point. Yeah.
I had a guy for a week straight trying to fix the internet around here. I mean, for God's sake, just do it once. Do your job, Drive me nuts. Damn thing was off all the time. I ain't bitching.
Nathan, I did that here, man. I literally drove myself insane. I made my own homemade outdoor Wi-Fi repeaters and put them in like a mason jar. I made the collector. You know what I mean?
Yeah.
Trying to line it perfectly to my brother's and try to get the signal just right. Like right now, everything's functioning because I have the TV angle just right, and it's just like grabbing that 5G.
Well, I mean, right? It's like you're using principles of old to just deal with the new. It's good.
Joe,
Yeah.
stop messaging your girlfriend. Pay attention, man.
I'm not doing anything, man. I'm just sitting here.
You know what would be more interesting is they had a pulse wave in Egypt, right? On that pyramid. Underneath that water was under there pulsing at all times. So if they basically just got the frequency right inside the pyramid, you can have whatever you want. Now, if you change the frequency, you could change anything. And if all you have is a fractal antenna on the top, you can communicate anywhere across the world at any time to any other pyramid that was doing the same thing. You literally had a communication system all around the world, but you also had a power plant because you can't get away from the fact that that type of energy would still create power. You know what I mean? So
Yeah.
even in small part, you got to think about it in harmonic tone. So if you built a pillar somewhere and that pillar was part of that harmonic frequency that was coming off of there, no matter which waveform it was in, quarter, third, whatever, then that would produce energy, and it would produce energy all around it, right? And so you can go on doing this all day long, you know what I mean, everywhere, and pick up energy throughout the whole place. It's just not as recognizable to us as it would be to them.
All right, I'm gonna go take that whole idea a little woo for a second, and I'm gonna say that, yeah, I kind of believe that one of the things that we really dropped the ball on was, you know, how there's these pyramids all over the world, you know, and how they kind of how there's so many similarities from culture to culture across the world, not only about you know, how it's all documented in certain events that have happened and so on and so forth consistently, but also just through different technology emergences, and how similarly they were ultimately done. And that raises the question of that communication and what that communication may have looked like, because I think that one thing that's kind of missing from the record, one thing that maybe threw us for a curveball for a long time was navigating and transportation on Earth. You know, they to think that they were just sailing around and going from place to place, figuring all this out and spreading the word and getting it done and all of that. It just seems probably not to be the case. You know, imagine that this fractal antenna, this communication device, was actually bridging the gap between point A and point B to where, like, you know, you'd walk into the resonance chamber and you'd end up the other side of, you know, the world in another resonance chamber that was in, you know, sync with it, you know, as
like
that form of
teleportation?
transmission. Yeah, like teleportation, exactly. Like, and I think that it's like a far, like, our minds like stretch and reach to that, and it sounds kind of funky and sort of out there, and we've played with the idea before, but so how come there's so much absence in the historical record as of any other way of getting around, yet there's all these consistencies?
Yeah.
You know, you know, yet we have these unexplainable, you know, formations that seem to have a purpose, and the purpose could very well be that, like, as one of the functions. It just seems like, you know, show me another way that they got around regularly, and then I'd say, oh, okay, well, there it is. But nobody has.
Heart ruts, man.
Didn't they use the crystals in the sun in order to tell them which way to go in was it the Vikings or something like that? When they went around the earth. So if you basically had the frequency, you're able to turn these things on and off when you know the exact direction you're going. I mean, we all can bring it down to a level where we can understand it now, but there might have been prehistory to that they used them for a different reason. you
Yeah,
know?
for sure. This stuff's been in use for a long time.
There's crystals in your brain that tell us naturally that detect the Earth's magnetic field. I forget what they're called. They're related to
Well, there's
like,
magnetite. There's magnetite in your brain.
yeah, right,
Yeah.
right, Joe. So you're not completely full of shit.
Well, hold on. So
Well, no, not completely. Just 90 to 97.5%
let's,
bullshit.
I'm
let's
joking.
look at it a different way. What if the birds are high enough in the atmosphere that they get a different energy than we get here on the surface? So theirs activated while ours isn't. You know what I mean? It could be the constant just flying up high enough in order to activate it in their brain where ours isn't.
My brain's exploding right now. That's fucking crazy.
Yeah. Well, I mean, that makes total sense because look at the different atmospheric flows that occur at different altitudes, as we like to call it, from the relative surface of the Earth, right? And you have all these different flow patterns of, energy that occur at every different level. And there, the higher up you go, the less complex it gets. And each higher level tends to be a bit of a root cause of its interaction with the next level and the next level and the next level. So when you're up there and you're out of the most chaotic level being the surface of the planet, there could definitely be more pure waveforms that exist that could possibly tune in with certain animals or whatever to help in their navigation. But mind you something too, like migratory animals, okay, they migrate, but most migratory animals are either in the air or the sea. Most. Okay. So what does that tell you? It's either transmission through water is a pure source of that type of energy. Okay, or you have to get off the surface of the Earth for it really to be taken to its highest advantage. I'm not saying that terrestrial animals, on like mammals and stuff don't migrate, but they don't to the extent of avian and fish. Like those are migratory animals.
Okay, so what if I just told you that the energy in our atmosphere is hot and then in the ocean it's cold? So you could be on a cold magnetic field, you know what I mean, in the water itself, just like we create with our Tesla coil, and then hot energy in the atmosphere. It could be two different reactions of the same thing, but we're standing on a dielectric plane. So we're standing on the very point where it flips between both. So we're just in saturation in the middle, but they're not. They're playing on both sides of it. It could be as simple as that.
Yeah,
we're in a Q zone.
We're always grounded, or we're near ground, so we have less going on. 100%.
Right. And there's your root cause right off to show the differentiation between why this and not that as frequently. Like it's.
But wait, what about whales? What about their navigating abilities? How would that affect play out in water, in a saltwater environment?
Well, the same as fish. I mean, fish migrate constantly.
Fish
aren't
the same as whales.
I'm not saying that whales are fish. I'm saying that they're in the same medium as fish, and the mechanism could be similar or the same.
Well, they also have the water that flows underneath the water, so it goes in channels. You know what I mean, around in the earth and stuff like that. So, like, I don't remember what the actual name of it is, but they get in there and they follow it. You know what I mean? And it's like a stream of water, like structured water that gets them to the next point. You know what I mean? And they migrate that way.
Transatlantic, no, not oscillation, but the
Atlantic current.
Currents, yeah, currents.
Yeah.
Well, I mean, I've never really thought about this in particular before this very moment, but one other thing about animals that live most of their life, if not all of their life, in water as a medium, right, is that they are mostly water too. That's of their immediate area. And then they are also within it. So they have, I would say, my sense is saying that there would be a greater state of equilibrium that they exist in. okay, which would actually allow them to pick up on more nuanced differentials that exist in their environment as well. So,
Yeah.
we drink water from a lake and then walk away from the lake, or a faucet and we walk away from the faucet. We don't exist, within that. So what we are majority of, we are not within, and whatever, esoterically, it goes right back to like baptisms and things like that, of that nature too, right? You bathe in what you are mostly of and become pure of it, right? So where there's just a high degree of why we would be less sensitive in certain regards than like a fish or a waterborne mammal, for instance, just because they are literally mostly made of what their medium that's surrounding them is, where we are not.
Has anyone? I don't know if anyone's experienced this. I don't know. I'm kind of in the woods here, so there's less distractions. But if you on a full moon, I can feel myself drawn toward the rising moon, or just become more active. And there's measurable effects on the water and on the earth energies that you can measure in the ground.
100%. Yeah, absolutely.
You get a lot of energy reflected back off of the moon from the sun to the earth during the full moon.
See, I knew you were a lunatic.
Oh, absolutely. 100%. That's why I'm here.
No, he's not telling you he becomes a werewolf at that time. You know what I mean? That's what he left out. He gets more energy, all right.
That's when I torque.
Probably more like a weremoose because he's Canadian.
That's right.
That's not right.
I live with a moose, man, on a mountain. I'm not even joking you. I was cutting up on a not a mountain, but it's like really out in the boonies. And man, I could hear this thing coming through the woods at night. It's 11 o'clock. I'm getting ready to go in my camp, and hear this crashing through the trees. It sounded like a tank coming through the woods, right? So I'm like, fuck this. I'm jumping in the skidder with the cage. I'm like, get me the fuck out of here.
Oh man, I was gonna say you should eat some shrooms and try to ride them.
Oh my god, dude! I almost drove under this animal. It was that big. I had a little what the hell, Chevy tracker, like a little off-road rig, and it walked out in front of me, and it's massive. Like I could have drove right under it. Huge,
yeah, man, they're big. They really are.
Beautiful animal. Just a little funny story. My lumberjack stories.
Yep, bull neck moose face, heavyweight fighting champion of the world.
That's the one animal I'd be afraid of in the woods. The bear didn't bother me. I chased it away with the chainsaw several occasions, but the moose, no.
The chainsaw.
Just randomly out there, throw that one out. Okay.
I mean, you could have just done the, oh! Like that probably would have sufficed.
we were like it was fair game. He trashed our camp. We had tents in the beginning, and the guy working for me, he said, "Man, there was something outside my tent last night, like snorting and growling." I'm like, shut up! You're full of shit. It was a squirrel or something.
Snorting and growling.
The next day we come back and our tents are just mangled. There's like chop marks in the lunch cans, and then I see the bear, and I'm like, okay, well, what do I do?
Oh yeah.
And it actually worked. After a few times, he stayed away, and we didn't have to call in Department of Dickheads, whatever they are, to
that's good. I mean, honestly, they taste like crap, so there's no resolving that problem amicably.
I didn't want to see it die. Like we were in the wrong on his territory, so fair enough.
So
yeah,
fun,
man. I eat any kind of jerky in the world, man. I had bear jerky one time. I was like, yo, terrible.
Oh.
Might as well eat goose jerky. That tastes like shit too. They're Canadian geese. Those things, they taste like shit.
Oh, that's funny.
Man, I'm an ethical hunter, but back when I used to do a lot of duck hunting and stuff, man, like you just sit there and like, take home a whole bunch of nice birds and whatnot, and usually eat them or whatever. Like some of them taste like crap, and it is what it is. But you try. But man, I used to just put down Canadian geese right into the marsh and be like, "Up, he's in the marsh." So if he landed in the water, I'd go get him. But if he was in the marsh, it's like, sorry, buddy,
That's what
you
happens.
crab food.
That's what happens when they fly south.
Yeah.
Mm.
Well,
So
that's
what was that
because
rock
they
you
didn't
had?
file their migration paperwork properly. So, Trump gave me the go ahead to shoot him with some, steel pellets. That's that.
Man, he's all business, eh? I know you guys don't talk politics on here, but
Yeah,
we won't
except for when we do.
I mean, there's some serious changes taking place right now.
Yeah.
I don't pledge allegiance to any one thing. I'm in the land of North America. I'm a human. I don't really care what happens in politics. I do my own thing.
Gotcha.
Yeah.
You guys,
Right now, it's all beyond our control. Regardless, it'd be nice to start seeing airplanes stop falling out of the sky, because that'd be cool.
Yeah.
Yeah.
We could do without that.
What do you think happened there, Nathan? Or chat people? You guys would know.
Where, which one? The one that hit Philadelphia? I think it hit a mall or something like that.
That was a
Or-
mess, man. There's a lot of footage of that.
Yeah.
There's more-
I'm sorry, what?
There's more than one.
Yeah,
Yeah.
that's what I'm saying.
There's there's one, New York, and they had a helicopter, a Black Hawk hit it. So
That
yeah.
was in DC.
That was in DC? Okay.
Yeah.
Wow, I
That
don't
was
live
in
out there, so I don't
and
know.
then a friggin' Learjet just fell out of the sky in Philly.
Wow.
Yeah.
Yeah,
What do you
I
think?
mean, listen, I'm Mr. Conspiracy Theorist, and I love attaching myself to that shit. But at the end of the day, I don't know, man. It just seems like a bad week. That's
Yeah.
what it kind of seems like to me, is a bad week. I don't really think that there's any sort of real bad stuff going on, other than misfortune and maybe some idiots at work. As far as making mistakes.
Right. And it's like the UAPs, like I told you. Like we like to put the pieces together and form this elaborate theory on everything, and really it's just natural stupid humans.
Didn't that congressman tell us there was a mothership?
Yep.
What happened to that guy? Yeah.
What?
Where's our mothership now? I'd be asking that every single time I talk to him. Dude, where's my
Look,
mothership?
I didn't buy that shit for a second. I'm sorry. The mothership and China and this, and I was like, people just stop. We know what it is, but at the end of the day, obviously they're not trying to tell you. Read in between the lines and be pissed off that they're not telling you what it is, because secrets aren't cool when you're the one flipping the bill. That's the reality of it. I get the need for secrecy in some things. I understand. But you can't take my money, spend it on crap, and then fly it over my head and then tell me that I'm out of my mind, because this is where I start to have a problem with it. That's where I start to have an issue.
Yeah. Just tell you what it is and then get over it.
That's it. If you want to keep it secret, then fly it in the desert. Use
Yeah,
it over a war field where, literally they're talking in a different language 5 seconds before you blow them up. Okay?
It was Iranian mothership.
What was with the eggs? You guys were talking
Oh
about
my God, the egg. Oh, that piece of junk. It's a real egg. It's not a UFO. That's an egg.
Yo,
Oh, God.
I saw that and I was like, Jesus H. Christ. You can't, you got to do a better job faking this stuff if you're gonna. That's it. Can you at least, this is 2025. You could fake something really good if you wanted to. Really good.
Can you show me? Because I paid no fucking attention to that shit. It's so dumb, right? But it's funny.
Hold on, guys. I'm looking for that egg. Go ahead and talk. I'm looking for it right now because that thing is just ridiculous.
Yeah.
Bust out the memes. Bust out the memes, Nathan. We need some meme action right now.
Right. It was like an egg duct taped to a piece of fishing line
Oh,
that they looked at through like the carpet, like through like a green filter, and it's like definitive evidence. I'm like, oh, no, here we go.
Was it on the mainstream media?
Yeah, actually it was. I think like Newsweek put it out or something. Yeah.
See, just distractions. It's like, man, they think
I don't know.
they're-
I didn't really pay much attention to it, other than I saw the picture and I was like, "Yee, God, you got to do better than that."
yeah, here it is.
tinfoil hats.
Dude, that is
There it is. Egg,
That's a
duct tape,
real egg.
fishing line, and carpet.
What the fuck is that supposed to be? What's it supposed to be? Allegedly.
Dude, that was the poorest excuse for a UFO like ever. They were totally trolling us.
Man.
No, well, not to mention that the guy looked like he was like on friggin' Molly the whole entire time. His eyeballs were this big with his like massive dilated pupils and stuff as he's telling the story. And I'm like, yo, this guy's either a total sociopath or like he's on drugs. I'm not really sure which. It's hard to tell
Yeah.
the difference.
Yeah, that guy was not reliable at all.
Oh yeah, no, he was definitely not a great firsthand account of that. Not at all.
No, dude, this is the funniest thing in the world, dude. That's just an egg. Like I don't know who was fooled by this, but it definitely wasn't me. As soon as I saw that, I'm like, dude, I can create that in a few seconds. Maybe I should start making egg videos.
Right. The funny thing is, you can see like the guy's finger in the photo too. It's like, and then it out, nah. Oh no, that's not a finger. That's a rope. I don't know. Is that a fingernail? Fuck out of here with that shit.
What's the story like? How was it portrayed? Was it supposed to be UAP?
He's a helicopter pilot, and he was put on a recovery mission, and they recovered it, and he couldn't believe what he was seeing, but knew it had to get out there because he was appalled by the secrecy and non-disclosure, and he pulled out his cell phone, and yeah, right. See what I mean? Yo, look at that guy's pupils. Yo,
Look at
yo, he'd fail a field sobriety test.
Hey, he was a helicopter pilot for what? Some kind of special
Oh
operation.
my. That's so bad.
He's a puppet, CIA punk. Come on. Nathan.
This is what they wanted to find right here.
Yeah, for real. AI did a nice job on that one.
Yeah.
Too much, Tony says too much Coke or something.
Right. This is what I'm saying. Like, he's got the eyes of a straight sociopath. It's scary.
Oh, dude.
Like, very concerning, man. To be like, look at me like that. I've been at the plot a way to kill you.
He's fucking
Oh, this is more what it was like right here. I'll show you.
Oh shit. We need a laugh.
That's the mothership with all the little UFOs around it.
What? Nathan, you must have been all over this one. Were you?
Oh my. Dude, this is just bad. This is the jokes they're playing on us. This is their UFO party, man.
See, they're definitely from China, bro. Yo, look at the eyes on that egg. They're definitely from China.
Oh my god.
Not to
It looks
mention
like a
all the
geisha.
Chinese soldiers running around.
Okay. While all these stupid UAP hearings where everyone was glued to the UAP hearings, I'm like, this is a distraction because Trump's coming into office. And I'm a Canadian. It's all a crock of shit. It's the same with the truckers convoy hearings. They were supposed to be, everyone was supposed to be, like this happened in Canada. Everyone was put on a little podium and put on a show for a week. It just wasted people's time and attention to divert it away from something else.
Yeah, they did that here too with the dock workers and stuff.
Yeah, man.
And that guy was mad, but they put him all over every channel to scare you to think that you weren't going to be able to get your goods anymore and prices were going to skyrocket. You know, hey, listen, it was an effective negotiation tactic, but like at the end of the day, like there's a reason that you're seeing it.
psyop. When you see any shit like that, you have to question it.
Absolutely. Yeah, the whole premise of that was junk too. He's like, we know we're going to be replaced, so we want more money for job security. It's like, wait a second, man. Do you understand the inherent conflict with that?
No, they didn't. They just wanted the more money.
Yep.
Oh yeah, it was 100% psyop. There, you're right. It was a joke. That was bad.
Yeah. Definitely it's psyop.
I'm reading
100%.
through comments, and it's like, well, beware of Easter 2025.
Yeah.
If it could gold would be a Mother Goose story.
Right. Right. Time
No.
traveling Easter eggs and such.
Oh,
Zip it around the room.
Dozens of boats going deep into the ocean.
I just can't believe the reporter sat there with a straight face as soon as the video come on. Like, he knew it was total bullcrap when he started building up the story really big before you show a few seconds of footage. He knew it was all poo, man.
Oh,
There was no getting around it.
yeah. Well,
Like
I guess they got to make a buck.
all these mainstream media companies are the majority of them are owned by one larger corporation, and they're very
That's it.
they have a narrative. There's an agenda, and it's just to put out bullshit and distract people for the most part.
Yeah, and then you look at guys like Stephen Greer or whatever his name is, and he's full of shit too. You know,
Yeah,
Is that the guy that says, if I told you what I knew, I would be dead, and then tells you nothing?
yep.
And that's his whole shtick. It's like, by the way, I know everything, but I'm telling you absolutely nothing.
Because I'll be dead.
Yeah.
But right, and by the way, if you kill me, then everyone's gonna know. It's like somebody. God help me, I'm not gonna say what I was about to.
Now, finally,
All right, well, we want to know. Expedite the process. No, I don't want it. Like he seems like a good guy. I don't know that he's full of shit, but like, I mean, come on. How come nothing you say ever comes true, bro? Because you're not telling the truth, probably, or you got to do better. That's it.
Outer Order satellite.
Hey, Joe.
Yeah,
you fell for the UAP stuff. Come on.
I didn't fall for the UAP shit, bro. I have hours and hours and hours worth of stuff of me saying that for UAP stuff.
Yeah, I don't like that, man. If you're gonna come on and talk about it. You know what I mean? If you don't know anything, shut your mouth. That's who he is. He does. I don't. Even if he did know something, if you're not gonna tell us, don't bother with the whole video. Just sidestep it and move on, because you got nothing.
That's it.
The CIA has a long history of doing this, especially in the UFO community, putting out bogus stories and just more or less crediting these people. If there is any truth, like, of course they have reason to cover these things up for national security.
Yeah,
and
bunch of schmucks.
Bunch of schmucks. Yeah, they
Bunch of schmucks.
the bullshit here and there.
Schmucks.
Yeah,
Schmuck.
discredit them. Okay, back to energy stuff. I like energy. Fucking.
Oh. We're just getting into the
This
biggest
segment
schmuck
was
of them
brought to you
all.
by Monster.
Yeah. Oh. Some of this stuff is too good. Like Jack Stafardi, man. He told you. By the way, I did a video once of him and cut out all the garbage from everyone else. And it actually just had phrases of what he thought, right? The real what he thought. And it's hilarious to know that he actually knows what he's talking about in like an underlined level where everybody else is just saying schmuck. That's what's hilarious about it. Hold on, I'll pull the file real quick. Let me see if I have it.
Yeah, definitely do. First of all, the schmuck thing is just too good not to. It's too good not to let go. Like you can't let go of it.
All this is time travel.
Oh, hold on, here we go.
Let's get this very straight. It's all time travel. As soon as you can control gravity with small amounts of energy, that's time travel. That's all, because the gravity field is the field of space-time fabric itself. If you can manipulate gravity, you can manipulate time, space-time, and you can travel in time. And I could go into detail. It's called tipping of the light cones. You have to read Roger Penrose, and it's well-known physics, elementary stuff that you guys really have to learn the math. If you don't know the math, it's just like a bunch of the photons inside the red materials gain arrest mass, and so do the gravitons, both the electromagnetic and the gravity fields inside the metamaterials. When there is a Freudic condensate, which is like a room temperature superconductor,
Yes.
they get effective mass. But so what? Yeah, they do. That confines them. So they don't leak out into space. They're not like ordinary gravity, although they couple with ordinary gravity inside the metamaterial. Control K in G equal KT and control the universe. G equal KT is basically Einstein's gravity field equation. K is the coupling between matter and gravity. And if you could increase that coupling constant, everybody thinks it's weak, that it's small. But obviously what the UFOs are showing us is that there is a technology that's able to increase that coupling, and then you can manipulate gravity with very small amounts of energy. There's a coupling constant that couples, say, the electromagnetic.
So hold on. So far, if you cut out all the garbage that was going on around him, right? Then it sounds pretty smart of what he's saying, because it sounds right.
You did a wonderful job editing out all that bullshit, because honestly, you can't listen to it in its pure form and get out of it what you put together, which is awesome. It's great that you did it.
Yeah, hold on. He's got more. So it's just interesting. Watch.
But hold on. Before you start it, though, what he just said, for those watching, that's the fundamental principle of exactly what we've been talking about this entire episode. The coupling is the same as saying that the differential. And when you increase the densities of the differential, that is the breaking of the coupling. So thank you, Jack. I appreciate that.
Room temperature superconductor has to do with the hot and cold of the room versus the actual machine that you're using. He's using temperature differential to make a room temperature superconductor, is what he's saying.
Right. Well, doesn't this happen with static as well? Like I noticed with my wood stove, if I increase the heat in my room, I'll increase the static field. Huge amount of static.
So here's the thing. The two fields that work together is the static field and the cold energy from the center of the Tesla coil. Those two work perfectly in a field together. That's how you're starting to create it. Yes, those two fields. Specifically those.
I want to use the electromagnetic field to generate a...
Sorry, go ahead.
Okay, like let's say, for example, in a thunderstorm, you have high pressure and low pressure, swirling around one another. And that's where you get these huge static discharges, or whatever you want to call them.
Mm-hmm.
But you can still get it, even though there's moisture in the air. So is it really dependent on moisture in the air, or does that eliminate the charge?
It depends on the hot and cold.
Well, that's also the medium in which of the flow medium is the moisture in the air. The potentials are always there. And that's a great example, because we consider it high pressure, low pressure systems, but you got to remember that in the high pressure system and the low pressure system, you have a temperature differential also. You probably also have a charge differential also.
Yeah.
It's two sides to every coin, and it's at the point of the gradient in which they meet, which is the zone of interaction. And it's that zone of interaction that is the manifest of the intensity of a storm.
Well, here's what I find, and anybody can call BS on them, and all of us did. The fact of the matter is, when you cut out all the other garbage, the underlying facts are there. Yeah, that's the thing. So let's listen to the rest of it real quick.
That coupling constant is very weak. In fact, it's the inverse of what Sal Paez calls the superforce. It's a reciprocal of superforce, and it turns out it's 10 to the minus 43 reciprocal newtons of force. That's the coupling. That's the coupling that Einstein used in 1915 when he, in order to show how his general theory of relativity reduced to Newtonian gravity, and with bending of light, all that stuff. So it was a purely empirical thing, and for very stupid reasons, everybody in physics, almost everybody in physics today, thinks that that's a fixed constant. You can't do anything to change it. And in that case, it's in warp drive. Actually, if that constant, the inverse, I'll use Pei as this thing, the inverse of the superforce, if that is fixed at 10 to the minus 43 reciprocal newtons, that would mean that UFOs could not exist. So we know, since we know the UFOs are flying around, Commander Forever tells us the Tic Tacs, all that stuff, and a lot of other, evidence for it. So we know that that assumption is wrong. And once you realize that basic belief, it's like believing in the Immaculate Conception. It's a religious belief. Physics is based on evidence. The evidence is that that's not true. And as soon as you realize that's not true, everything falls into place and we understand it.
Yeah.
Jack knew the whole time. He told him right away he didn't have it because he knew he didn't have both sides.
The difference is that it's like he said, clear as day. It's not a constant; it's a variable.
Yeah.
Once you realize it's a variable, then all you have to do is vary the variable.
I think what my question is, where did the physics community start to just go completely off track?
I'll tell you where they went wrong. When they look at it, they go, "This is the concept of it," or they always take it as the law of something when it's not. They say, "What's that word that's always used? This." Sorry, it's boggling my mind right now. I'm looking for a very specific word. Theory. They say this is a theory of gravity, right? Instead, they erase theory and they write law, and it ruins everything. And by the time they're done, they have all these laws that they abide by when it says theory. And they didn't realize that. And they keep going up to you. Oh, what about the theory of this? What about the theory of this? Well, it's not a law, buddy. In your head, it is. In the rest of us, it's not. It still says theory.
Well, that's the idea of thinking outside of the box, is that if you lock yourself into all these constants and laws all the time, you will never find anything outside of them. That is your box. These laws are your box. Once you realize that the laws are mostly true, but also variable, and then you're able to input different figures into those variables and know how they're influenced and make those changes, all of a sudden you're no longer in the box, and then you're on the fringe think tank. That's how that goes.
You might not have.
And they say, well, this is the framework, but here's the thing: is that the framework could exist, but just like any framework, you could have stuff inside of the framework, and then you could have things attached to the outside of the framework. It's just how it works. It doesn't, just because you're outside of the framework doesn't mean that you're disregarding it entirely. It's just a train of thought. That's it.
Well, I tend to I'll see maybe a science article come out, and it's always for reasons we don't understand or we can't explain. When they make an observation out in space, they're always disproving the settled science continuously. But
what did you get a new telescope and it destroyed their whole understanding of physics out there in space?
Exactly. Yeah.
I mean, for God's sakes, man, that's horrifying. What about all these hundreds of papers you wrote about all the stuff in space that all sounds like BS?
Yeah.
Nobody wants to look like an idiot, so they just push it under the rug. And
they hope you didn't see it. They hope they just put it out there. Oh, forget we even said it. Yeah.
Oh man, quit writing stupid equations and get out there and start experimenting like you guys are doing, like we're doing. Then you'll understand. You're not gonna figure it out writing fucking math.
Or be like me and do none of it and just talk about it and be wrong.
Yeah.
Just be like Joe. Joe, you've done stuff, man. Come on. You
Yeah.
understand things. in different
I've done a
way.
thing or two, and that's
Well,
it.
now it makes perfect sense when they talk about the egg, right? Because they told you so much garbage for so long that you'll believe anything. Like with the
Yeah,
Diamond Planet, I was watching that show on planets, right? And you get all into it, and it says like, "Oh man, that's the coolest planet. It's all water. This one's all diamonds. This one's, you know what I mean, all this." And they go, "Well, how do you know?" They show you this tiny little speck on a radar, and they said, "We got it from this." And I'm like, "What the fuck is that?" That's like, is that like an extra thing? You blow your nose or something, and you found the speck, then you analyze your booger. I mean, dude, this is bad. Like, how did you get a diamond planet out of that?
Well, you know what's funny though is that they spent all this money to get some imagery that drew them to that conclusion. When you and I, about 4 or 5 months ago, followed just a logical thought process that ended up in us postulating that the center of Saturn and Jupiter may very well be diamond, just based on its composition and placement in the solar system, and all you had to do was follow logic to be able to achieve that idea, and it's just as confirmed as their stupid fucking imagery that they drew this conclusion from. So what's the difference? You know, what's the difference? It's not conclusive what they're showing, and nor is what I'm saying, but it cost a lot less to do it my way.
It's like there was a division 100 years ago, and one group, one faction went one way, one went the other. It's like Birkeland Current did the experiments under a vacuum, and he observed all the phenomenon in the solar system. Where did we go wrong? What happened?
Here we go. Generic Jabber. Boogernomics. That's how we went wrong. The boogers on the screen. Just terrible.
Flick it.
Right.
Some mesh of space. But is there a mesh? Is there a fabric? Is there an ether? Is there a field? What is it?
All that and then more that we're not talking about, because the more is just the mechanism of it all.
Yeah.
Are we all talking about the same thing? Just different terminology.
Always, because everything's all the same thing.
Yeah. I think you just keep seeing fractal representations of larger and larger, the same phenomena as an atom, as a solar system, as a galaxy, so on and so forth.
You really want to understand something? Understand that the fields that create free energy, time dilation, antigravitics, are the same exact interactions that you have in your personal relationships with your loved ones and associates. Once you get your head around that, come talk to me, because now you're awake. Like they're all it's all the same. It's all the same.
We have the chakra system. We have the same energy torus that goes through us and out and radiates out around us, I believe. I've experienced it.
Yep.
Yeah,
That's
I
it.
got energy
These
that goes
interactions,
through me
they
and
all work
radiates.
the same.
Sorry? What was that?
I said I got energy that goes through me and irradiates, and it comes out bad in the morning. I'll tell you that. Don't eat burritos the night before.
I was gonna say, is it mostly methane?
What do you shock your burritos and eat them, or what?
It builds as a gas, so it stays in the air in that potential area. How about that?
I'm surprised that wasn't part of the Green New Deal. Is piping your ass for methane for clean energy consumption?
They got corks with logos so the congressman can put it up the cow's ass so you know who did it.
Creating awareness, flammable potential. Yes.
Oh my God, dude. It's your locality to the fart. That's what it is, Joe.
You're not kidding. Well, I said, if you want to get rich, just sell a Democrat a fucking exhaust pipe for a cow's ass, and then then you can eat all the steak you want and be rich while you do it.
They're gonna sell them thunderstorm generators for cows' asses.
I mean, honestly, I drove by a farm this morning, and I'll tell you, man, they got plenty of output. There ain't no lie in that, man. I can smell their ass from 250, 300 feet away, man. It's like with the windows up.
It's like driving by a skunk. It's just
Oh,
everywhere.
yeah. You wish it was a skunk. Oh my god.
Oh, I
You
said
know-
that shit science.
Before
Shit science, that's right. It's all shit science.
focus. This is hilarious.
We're quantifying the shit field.
Before, Nathan, did you get any of the videos I showed you where my sounds and movements? Where you guys are so fucking laughing. My sounds and movements after I zapped that screen with a high voltage, high capacity discharge, and the screen was reacting.
Hmm.
Are you-
I
I'm looking
saw
up-
it. I remember that. I don't remember which video it was. Oh, yeah.
You know what makes all that interesting is it's the observer effect, right? And like Nathan said a trillion times, you know, and what Brandon experienced, it has to do probably with like capacitance, right? A change in fluctuation and capacitance in the ambient area of the screen. So that makes you think about observation entirely differently, doesn't it? Where not only the presence of something has, you know, the potential to interact, but the you know, like that could change the way that you think about what constitutes an observation, which is something that science really struggles with. Like, it doesn't matter what kind of science. I think that the idea of observation is struggled with by and large. Like,
Well, yeah,
what,
the double slit experiment. As soon as you turn on a camera, you're creating a magnetic field in the room. As soon as you stand next to it, you're creating energy in the room. Buddy, you can't get away from it. Yeah, it's you causing it to change, but you're not realizing the underlying cause. You're just looking at the effect. It's you. It's what you're doing. It's what you're turning on. It's the field you're creating. They just totally out there on it. It's like, oh, it's a miracle. No, buddy, it's
No,
not.
I'm always speculative. I always, practice good scientific. I try to explain things with what's known already. I don't believe in magic, but it was very unusual in the fact that, if it was just body capacitance, like when I add a capacitor to the screen, it doesn't do that. I mean,
Yeah,
it's
but
just-
hold on. If I
phenomenal.
sat over, if I went over by my Tesla coil and I simply walked next to it, the capacitance in the coil changes immediately. It interacts with the field. So it could be a grounding effect to your body. It could be your capacitance adding to that field. It's all relative if you understand, how those things work. But you would have to, be around this kind of stuff a lot to understand that that's what's going on.
Yeah.
So
Yeah, it was
Yeah.
just cool. It was cool to see. I could rub my hands. I could make a certain frequencies in particular would make the screen start sparkling everywhere. No power going to it. And
Yeah.
it was in a particular configuration through the vacuum of the screen, the positive, negative, and the aluminum plate, which was earth isolated ground, and then maybe a capacitor across one of them. But it would just keep going. It would just suck energy in and give it back as light. It was very, very interesting.
would have been a lot more interesting had you explained that in the video. Because I got a video that looks like this TV's going absolutely nuts, and I'm trying to figure it out. And I'm, what the fuck is going on here? It's a clown house or something. I'm going,
yeah, it's all over the place. I know.
This is late at night, man. I'm like half asleep. I'm talking gibberish. If I try to talk to my camera, then I really start questioning my sanity.
well, you should question your sanity. It's the middle of the night, and you're working with high voltage, and you don't know what's going on. I mean, yeah, I'd be a little worried myself.
I got myself with a fucking microwave cap the other night. I was stupid. I grabbed I grabbed the can, which is grounded. Don't ever do this. 3,000 volts going through it, and I grabbed the can and the positives and just fucking sent myself back on my ass.
Hey, don't feel bad. I took a voltage multiplier and picked it up once and didn't realize and took the whole charge.
Oh, that sucks. That's nothing to play with, though. Really, like it's fucking scary when it happens. I felt it right across, man. I'm like, oh, that woke me up. I wasn't asleep anymore. Yeah, stupid. Very stupid.
Yeah.
Well, it's in the name of science, right? And I thought I was the community idiot. I mean, you guys prove me wrong all the time with the shit you do and be like, yeah, man, risking life and limb just to, heat up to transmit electricity through a burrito.
I'm going to tell you right now, that was the funnest experiment in the world, lighting up burritos. Okay.
Yeah, I love that. I thought that one was great.
Yeah, because how many times have you seen people do that? Usually they just cook the burrito and eat it. So I could have ate my lunch, or I could have cooked it with my Tesla coil.
Did you taste it after you zapped it?
Did I do what?
Did you taste it after you zapped it?
Yeah, it tastes fine. They didn't do
Yeah,
anything
he had
but
to get
mess
all
with
the
water.
He had to get all the H benefits out of it that he put into it.
No funny tastes, or
No. Well, basically, it was grounding out everything, and then it was emitting pure frequency. So
wow.
it was making the burrito. Here's the chirpy thing: the burrito was hot, but it was not hot. Like if you put the temperature sensor on it, the burrito was maybe 68 degrees, but if you touch it, it would burn your finger. The total high RF in it, right? And
Wow.
it was just awesome because it was a burrito. It wasn't a piece of metal or something. It was just a burrito, a frozen burrito for 99 cents.
Was that a vacuum cleaner motor that you were using in your maybe 4 videos back?
Yeah, it was a vacuum motor. So that thing is like an amp hog.
Like energy from vacuum cleaner. Nathan,
That's right.
master.
Cold energy is the new MSG. You just put it through your food and.
Well, the thing with that experiment, man, is it just kind of sucked. Is I wasn't using any multipliers out of the system, and it got just to the simple: can I convert it and show people I convert it? And then they look at it and they go, "Well, you moved a motor for a few spins." It's like you don't see any potential here because you didn't see any multipliers go in whatsoever. So you just think I'm messing around with. Why would I put a power source into that through something else instead of just using the straight power source, which would make perfect sense if I wasn't going to put a multiplier on it. If I didn't spend the last 2 months telling you that we need to multiply this thing, then I would understand your comment. But no,
Well,
because I'm not an imbecile.
People don't understand either. You're studying the effects of it, and you're doing it at scale and using things that you have around you, which is what all the great engineers do, right?
That's it, man.
Now, use a fucking rock. Use a piece of quartz. I used, well, you don't see half of it. I used a blender the other night. I made an electrostatic generator. And
You made a static generator out of the blender?
Out of the blender, I put some styrofoam in. And I shocked myself, man. I'm like, whoa. Energy from the blender.
Oh,
He
did
sent
you
me
get
that.
that
I
on
was like,
video?
what are you doing? I was like, what are you doing?
No, you got to get that on video, man. I got to see that.
Okay.
It's shocking the living daylights out of yourself with a blender, dude. I would go to the yard sales and pick up every blender I could then. Okay,
And
let me tell you that.
this builds on what Jarvis was working on, right? Like the electrostatics, triboelectrically charging different materials. So I'm like, I'm going to try this, Just start jamming stuff in the blender, styrofoam chunks and stove ashes and whatever, just to see the effects.
You know how
Wow.
strange styrofoam acts when it's in when it has that level of static charge to it too. It does all sorts of weird stuff like floating and clinging and zapping and like all sorts of weird stuff. Like doesn't act like a normal just like little ball of foam.
Oh man.
Just polymers. It's just repeating chains of carbons, right?
Yeah, I had one of those beanbag chairs that has like all the little styrofoam balls in it,
Mhm.
and I opened it up because it's got a zipper and you could actually put more in there because they kind of get compressed and whatnot over time.
I
And
used to
yeah, so like I opened the chair up to see like I figured it was like in a contained bag within it. And when I opened it up, I was horrified to find that it wasn't. And then I did the dumbest possible thing I could possibly do, which was stick my arm into it to see if I could shove some of the bean bags in there. I took my arm out. My entire arm was covered in styrofoam. Couldn't get it off to save my existence. I'm sitting there touching door handles like, come on, and try to get them to, and they wouldn't stop. I'm brushing them off of myself. Then I vacuumed them up. That compounded the issue entirely because all that extra friction with it just it was already statically charged. Now it's all stuck in the hose and shit. I can't get it out of the hose to save my life. I'm like, this is awful. I wish this shit was covered in glue. Like
the poor
Yeah.
kitty with all the stuff stuck to it. The poor cat bean. And he's got a bunch of styrofoam just clung. I'm picturing Joe like that, like just styrofoam.
it was my entire arm, and then like some of it that I got off was on the floor, but then I stepped on it and then it was stuck to my foot. It was a mess.
So, oh, back in the day, you take some old hairspray or something with some sticky glue for aerosol. You put it on a big stick and walk over there and clean it all up.
Hey, that's smart. Yeah.
Start playing with that crap. It's all over the place. Those little peanut things that they put in your shipping things. Oh yeah, run your static electricity experiment with that, and it'll look like a popcorn machine's going off in your garage.
Love it.
You try different things, right? Like again back to what you have and what you can. Like I got so much junk here, man. I don't care if I fry it. If you pick this stuff up, let's say at a, I don't know if your town or anyone in the chat, if they do like heavy pickup, you can find plasma TVs, you can find projection TVs. Appliances are awesome to tinker with. You got connectors, you got wire, you got loads of stuff.
Oh yeah,
endless. Right, and the hobby doesn't have to cost you a lot of money. So
yeah,
that's how I.
Oh man, I caught the riot act from Brandon the other day when I told him that there were two massive LED TVs out by the dumpster of where I live, and he's like, "Go get them." I'm like, "Bro, I'm not like shit hoarding like you. Like, I'm sorry, I'm just not like taking them in for the sake of taking them in. Like, but no, Brandon's got like copious amounts of awesome usable things that he has the ability to store. So good on him for that, man. That's resourceful. Me, I just said, let the garbage man take that shit. I don't really care.
You know what? I might just do that. I'll take one of them TVs and I'll run some different energy through it and see what happens. They got to do something. You know what I mean? They're just sitting out there collecting dust. I might as well do something with them.
You mean to tell me you haven't zapped your plasma TVs yet?
No.
Oh, dude.
Oh, all the tube TVs get zapped. That's the first thing they get. Is they immediately get different voltages. I'm shoving stuff in the back of the hole, man, creating big balls of energy in there, trying to see what it looks like on the screen. I use the on and off switch from the remote to turn it on. No,
Cool.
dude, it's beautiful.
Okay, so
What I'm interested, and I've said this before, is like with Brandon's experiments, in what flashes, I'm wondering if there's like pattern sequences that are repeating or something that's able to, like kind of being put into some kind of context other than it just being simply random as to what's illuminating when it does.
100%. It's really frequency dependent, what kind of voltage you put in there, and what kind of environment. If there's any interference or any, if I play a tone from my sound system, I can tell when it gets close to resonance, and when it resonates, there's no power going to this plasma TV, but it starts flickering and flashing like crazy. They're usually multiples of like the key of G. Like you'll get it at 11 hertz, 12. I could be wrong on these numbers. Don't quote me on this, but 46, 47 hertz, double that. You know, you get around 100 hertz, it starts really going nuts. I don't really fully understand why. I have an idea, but it's the same when I play drums. I have to have them tuned to a certain frequency, and I have a
I know
preference.
why.
Nathan,
I know why.
You probably know why.
Well, because if you set your frequency of your transformer to the frequency of your oh man, I'm losing words like crazy right now. It's your tuning fork, okay? And you smack your tuning fork, it'll actually make energy in your transformer. Sorry.
What?
Total brain
Really?
fart there. Yeah, that's why. Because you could turn on the transformer inside your TV by hitting the right frequency. Simple as that.
That's cool. That makes sense too.
So that it changes energy for you, right?
Let me interject. There's no this screen. I don't know if you can see it behind me there, back there. There's no well, I do have a transformer hooked up while I'm doing the experiments, but then I disconnect it. So I'll zap it and then see what it does, see what it gives back. And because of the earth ground, like there's only a certain configuration that this works. I'll put a capacitance to ground, to isolated earth ground, similar to Tesla's, I don't know what he called it. He patented it, transformer, capacitor to ground. And you get energy back. You really do. It's wild. And it keeps going. If you get it right, it'll keep going and making light. But like you said, Nathan, that's probably happening. I just wanted to clarify that the TV it's just the screen. And I hook up different things to it.
Yeah, I have a video of it. I'm trying to look to see if I have it. Right where you just take a transformer with a tuning fork and turn it on.
That's wicked.
So it take me a few minutes, guys.
You start putting these things together and you realize that sound, like everything's connected in our atmosphere. All energy is, it's related in some way. Pretty wild.
Yeah, it's all got the same root cause, which is frequency. That's
frequency, velocity. I would think plays a role, and resistance, capacitance, whatever.
Yeah, but the velocity also has directly what to do with medium, and so realistically, is that that's just a variable, is all it is. Like at its root form, it's just frequency.
Right. Pretty wild. I learned a lot happened that TV. And watching you guys, like I said, this channel, man, it's awesome. I love it. I promote it any chance I get. I'm commenting on other people's. Go to Old Man Builds.
Yeah, nah, man, you're definitely our number one fanboy, bro.
I'm a fanboy. All right, I'll admit it.
But you're not anymore. Now you're famous.
I don't want to be famous.
Now you're famous.
God, this thing is like far down here.
Thanks, Joe. I'm famous, I guess. Man, and the chat people, again, I learned so much just reading comments. It's just my mind just, I get overwhelmed with information. I'm like, holy fuck. It's just explosions in my head.
I know it's hard to keep, like, I'm going to tell you from this side of the camera, and being in the chat too, it's super overwhelming sometimes to like be engaged in the discussion, and have to talk and think about like where you're going with it. And then also like then bringing in the input of the chat too. It becomes like, like a big thing. It really does.
It would take practice.
A lot.
Now
A lot.
See, while I'm carroting and trolling you, while you're live, and I'm in the chat, and like, listen to me, fucker.
Yeah, I know you're truly a keyboard warrior. You're the world's biggest fucking devil advocate, man. You're like the biggest naysaying little nanny boy I've ever met in my life.
You guys are
Love
bad.
you though. You're a good
Devil's
guy.
ad-
Oh man, I don't know what this video is. You hit like on the videos and then you go to try to go back through them to find them. It's a total disaster.
Play some plasma screen, man. Some sparkles. There was a few that I edited and sent you, but I mean, you'd have to sift through a pile of crap, I suppose.
All right. Well, if you can't find them, we could always do a rain check on that because, there's a bunch of them that are worth seeing. I think it would be awesome to like go through them one at a time and just kind of tell us what's going on exactly. Because even like you send me videos all the time with no context at all. I'd love to hear what you actually have to say about them.
I love that. I like making you think, and then you come back. You come back with this elaborate, crazy bullshit, and they're like, "Yeah, Joe."
Yeah,
That's
exactly. And you want to know something? I made it all up.
Yeah, probably. Just busting each other's balls.
That's it.
Hey, where's Sean? Where's Jarvis? Where's G-Man? Where's
Yeah, we have absentees today. My God.
Yeah, you know what? I'm disappointed.
That's not to downplay the people that are here because we love you.
I'm going full care. Committed. I'm on every live in the chat. I'm trolling everybody, even the chat members. It's my job, Joe.
Listen, you do your job well there, buddy.
Thank you.
There's like 3,000 videos I'm looking through right now just to find one.
You're zoning out, Nathan. No, you'll
It's
find
ridiculous.
it. Keep looking. I'm gonna read these. See, I'm blind. I'm like, put your glasses on, you dummy.
Like they have one where you turn on a
Later, G. John.
Yeah, catch you later, bro.
Thanks,
you
man.
turn on a transformer with a magnetic field. A tuning fork with a magnetic field. It's wild what these people do.
The metal of the fork also has sound waves traveling through it, John says.
Sorry,
Yes, it
guys.
does.
Gerald, have
Taking me
you,
forever.
Well, you got to remember that vibratory oscillation in a solid medium travels much faster than when it actually enters the surrounding ambient environment. So, it's that differential. It's like to do with the sound and the tuning of it and how it's ultimately transmitted sympathetically to anything in resonance with it in the surrounding area.
well, if you have listened to live music or play live music, when
See, John hit it on the head. Sorry.
When people are in harmony, or even when two instruments are harmonizing one another, there's definitely something happening magical, man, because it gives me chills. I'm particularly sensitive to sound as a musician. And when you get harmonies going, man, it's a beautiful thing. The first and the fifth, like when it's
yeah, but you know me, Brandon. I like Primus, which means I like dissonance. Because it's a state of dissonance.
Primus is fucking wild. That's different level of music. I like them though; they're really good.
Yeah, Primus sucks.
What?
Primus sucks.
You just said you like Primus.
Yeah, but that doesn't mean that they don't suck, bro.
Wow.
Come on. Les Claypool. Oh man, he's got
listen. If you know, you know. Everybody knows that
What?
Primus sucks.
What? Why, Joe?
Why does Primus suck? Because I mean they're just dissonant. they break every rule of music, and that's what makes them great.
Right. Well, no, but if you really listen to it, there's a lot happening there.
Oh, I agree. They don't
In the
really
riff-
suck. They just suck.
Well, I know what you're saying now. I understand. Yeah.
Yeah,
Uh,
exactly. They don't really suck. They just suck.
from a conventional music standpoint, yeah, they would be totally off the wall, right? Hey, Ulysses, yeah, Jack the Ant,
Ulysses. Yep. Jack the Ant.
longitudinal waves. Go to an open air rave. I heard somebody in the comments say that, I think it may have been Steven. He said that they created standing waves just with like a huge amount of sound speakers at a rave.
That's awesome.
Yeah, that's wild. Music is universal language. I agree.
Agreed. 100%.
It's like we're taking all that resonance and frequency in the environment, and we're making something beautiful out of it, right? With music. It's a magical thing if you experienced it. Or even listening to it. You don't have to play music to appreciate it, obviously. I like getting on the drums first thing in the morning. I crank the amp and just some heavy G, like jerk, just heavy bass, and that's when I practice. I don't know, it just brings me to life in the morning. Love it.
True.
All right, guys, this is pretty much a lost cause to look through all this stuff.
Well, Nathan, it's been almost 4 hours.
It's only been
Sorry, guys.
I'm freezing here. My feet are like, pretty sure I'm getting frostbite in my feet right now, but I don't care. The stream's awesome.
Yeah, man. Definitely was. And I would have lost money on the fact that you were going to click that link. I'd have lost money. And I didn't bet because I'm not a betting man, but I'd have lost.
You didn't think I was going to come on?
No. How many times have I told you to come on?
Never. You're like
Repeatedly.
afraid I'd steal your thunder.
Oh, yeah. Okay. Steal my thunder, buddy.
Hey, I gotta grow out my beard, man. Look at Nathan's beard. I was gonna ask him if he had any beard.
Yeah, I know. You're looking like womanly over there. I don't know what's going on.
I know. It's like a
You
whistle
guys are
beard.
bad.
The total feminine beard you got. And me too, though. I cut half mine off. You know, it's getting back, though.
Hey, it looks darker, Joe. Must be the sun.
You're an ass.
By the way, real quick, I just want to let you guys know that energy that we're working with, as I saw this, you see this right here? How he's
Yes.
getting that spark out of there? Just so you guys understand, I think that's concrete in between all of it. If I took that energy from the center of my Tesla coil, I have no problem getting the spark out of it, just like that. As a matter of fact, I can run it right on the ground on the concrete and get sparks right now.
Hmm.
It literally is that those things are wet and it's an energy transfer. Goes right through all the quartz and everything. Goes through all the feldspar in there, inside that the granite, everything. Spark has no problem whatsoever with that.
Creating awareness, Egyptian capacitor. Cool. Granite and other types.
Yeah.
Nathan, did you get the video I sent you where I was zapping the granite ashtray and with the carbon stuff flying?
I can look. There's so many, man.
You know what? I didn't think it'd be conductive like it was. And it was making weird noises and it just freaked me out. I didn't expect that.
Yeah, I'd have to. Hold on. Let me see. You said it was an ashtray or a rock?
Oh, a piece of granite I found at an old quarry. The company actually went bankrupt. And,
Where you pulled energy out of it?
well, I was zapping it with flyback. And I put some of my carbon creation, we'll call it. And I think I sent it to you, Joe, as well.
Yeah, I think I saw that. Yeah.
There was some major shit going on there. I'll show you the ash.
I don't know. We would have to. I'd have to go back through it because there's some stuff on there I can't show on the live at all. You know what I mean?
Yeah.
Right.
Fair. All right. Yeah, just for Ulysses, next week, if I remember, I'm gonna make a little alien emoji with my haircut on him. Yeah. So like
This is a red.
like a green gray alien with like a undercut man bun. Shit.
Oh, yeah, your whole thing just flipped, Joe.
Joe.
Yeah, it's like frozen and sideways.
Whoa. Oh shit, my phone's dying. Uh-oh. We need power.
Oh wow.
Oh
That's so funny.
Oh yeah. Oh, we got Stefan. We got some members who.
It said look up Sonic Energy. Hold on real quick.
Nathan, I found it. Look up Sonic. Okay.
Yeah, I'm looking it up right now.
Cool. Granite piezo.
So far,
I think granite would act like it would have piezoelectricity depending on what you do to it.
so I don't have the right stuff in front of me. I can tell you that. I got a bunch of people doing weird stuff. Yeah.
Most granites are high in quartz. Yes, 8. Absolutely. Yeah, they have some wild effects when you zap them with anything. It seems I don't know if it amplifies or just it sends out. I don't know. It distributes the voltage weird throughout the air. Just from my observation, I don't know how you could scientifically explain that. I'm sure someone could.
Yeah, look, I'm not finding it. All right. No, I'll just pull it up one day. I think Joe left. I think he's done.
Yeah, John.
There he is. Joe,
Yeah, my phone died.
You were sideways again.
Fuck.
In for the fun.
You just-
Yeah,
you just turn it- All right, guys, we're good, man. Yeah, it is like close to 4 hours, so let's just call it a day. All right, guys, I want to thank everybody in the chat. You guys have been awesome today, man. I'm trying to put up as many comments as I can. Thank you, everybody. Thank you very much for coming on, Brendan. Appreciate it. Thank you, Joe. Just all frozen. Right on, brother. Have a nice day, buddy. I'll see y'all later.